All across Team Blue, the team's been working tirelessly to ready this New Glenn mission for flight. Want to discuss our objectives? Absolutely, our number one objective is to deliver ESCAPADE safely and successfully on its way to L2 and then eventually onto Mars. We also are wanting to land our booster. If we don't land the booster, that's okay. We have several more vehicles in production.
The data that ESCAPADE will gather around Mars, along with knowledge that we have from prior missions, will enable us to better understand the space weather environment of Mars, so how the upper atmosphere of Mars responds to changes in space weather, so-called solar storms, which can belch out 1 billion tons of gas at 3 million miles per hour, and how the Martian atmosphere responds to that.
So ESCAPADE represents basically doing science at a order of magnitude lower than previous. We're doing it for, less than 80 million per spacecraft and launch, which is huge.
Really excited to see that mission go forward. Really excited to see, heliophysics' first mission to Mars and being able to deliver that space weather information that will hopefully help as humanity expands out into the cosmos.
Hello everyone, and welcome to Spaceflight Now's live coverage of the latest mission from Cape Canaveral Space Force Station. I'm Will Robinson-Smith, reporter with Spaceflight Now. Good to have you with us here on this Thursday at the top of the noontime hour. We are broadcasting, as we always do, from the Spaceflight Now News Bureau here at NASA's Kennedy Space Center. You're seeing a quick cameo by Bob, one of the recovery ships that SpaceX uses to scoop up the fairing halves for its Falcon flights. It's heading out today in support of what's planned to be a pair of Falcon 9 launches, both scheduled for Friday night. We'll, of course, have live launch coverage on those missions tomorrow, but we've got our own doubleheader today with a couple of big rockets getting ready to head up with some really important payloads for their customers. First on tap is the one you see here on your screen. This is Blue Origin's second New Glenn rocket, supporting NASA's ESCAPADE mission and a technology demonstration from Viasat. Later on tonight, we're looking forward to the launch of United Launch Alliance's Atlas V rocket, sending, as fate would have it, another Viasat payload, the Viasat 3 Flight 2 spacecraft, on its way to a geosynchronous transfer orbit. We'll have live launch coverage, dedicated coverage on that specifically, beginning about an hour before it's set to take off, with a window that opens at 10:04 p.m. Eastern, 03:04 UTC. But for now, our focus is here at Launch Complex 36, where in as soon as T-minus 2 hours, 54 minutes, 37 seconds, this New Glenn rocket will take flight and send those two ESCAPADE spacecraft on their way to what's being referred to as a transfer orbit, or a loiter orbit, where these satellites will hang out in an orbit kind of shaped like a kidney bean, as described by mission managers, where the satellites will wait until the prime opportunity for their transit burn on their way to Mars. That'll take the better part of a year to get out to the Red Planet. There they will begin to reorient themselves into their proper science orbit, where beginning in 2027 they will start their science mission. We'll have much more to say about all of these flights, both for Viasat and for ESCAPADE. And just a quick addendum to what I literally just said, the science campaign is set to begin in June of 2028, after arriving and doing some orbital corrections. As we're getting rolling here, I want to thank the team that is making this live launch opportunity possible. Of course, our Spaceflight Now editor, Stephen Young, is running the technical operations of our broadcast today. Our photographers are scattered around Florida's Space Coast, getting all the best angles on this New Glenn rocket. If you're not following the fellas on their handles at X, you can find them here. Adam Bernstein is at ABurnNYC. Michael Kane at MD Kane Jr. John Pisani is at John Pisani Photo. You can also find us at Spaceflight Now by just searching for the words Spaceflight Now. We are on Blue Sky, Threads, and Facebook in addition to X. We'll also be joined a little bit later in the broadcast by our friends Chuck and Jen Briggs with C&J Images, as well as Pete Karstens with Max Q Productions. Joining us right now, though, at the top of the show, a little more than 1,100 of you watching live. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream, allowing some more folks to find their way into this live launch coverage today. Looking here from Chuck and Jen's perspective on Merritt Island. This is the vantage point of the rocket looking from west of the pad straight out east or thereabouts. And of course, here in the Jetty Park area, we're looking from the south towards the north at LC-36. As we're getting things going here, I want to thank our moderators of the day who are helping us out. Looks like at this point we've got Jeff Hansen and Rick Donner on hand. If you do see any of the other moderators pop in throughout the course of the broadcast, be sure to give them a big old Spaceflight Now hello. You can help the mods make their job that much easier just by following the rules of our live chat. We ask that you post your message in English so that the mods can respond as appropriate. Also, that you hold off from delving into overt politics or religion, and don't post your message in all caps. Emojis are perfectly fine. We just ask that you don't create a huge block of them so that they take up a large percentage of the live chat. Last but not least, we ask that you treat each other with the kindness and respect that you yourself would like to receive, and we'll all get along swimmingly. That's a little bit of housekeeping here. T-minus 2 hours, 48 minutes, 40 seconds. If you have a comment or question about this mission or other goings-on in the realm of space or spaceflight, or just like to offer a little bit of support this morning, you can use the YouTube Super Chat feature. Not only will it be giving us some interesting things to talk about as we cruise on through the count, but you'll also be supporting what we do here at Spaceflight Now, and that, my friends, is always greatly appreciated. speaking of our supporters, want to thank, looks like Dave and Deborah Rhea for both joining us with channel membership at the pad leader level. Welcome aboard to the both of you. We're glad to have you with us. As a reminder, channel membership comes with a number of perks, including discounts at our online shop, which is shop.spaceflightnow.com, access to member-only videos here on YouTube, access to our members-only Discord server, and of course the ability to watch all of our live launch liftoff moments from here in Florida in 4K. Want to thank, and apologies for very likely butchering the pronunciation of this, but I'll give it my best, Morali Dharmalasa for a 40 rupee super chat. Appreciate the support today. Also thanks to K2 Hat for a $2 super chat saying good afternoon from Miko. Hope it launches today. You and me both, K2. You and me both. Also thanks to my mother, Mary Robinson, for being with us today and for supporting with a $10 super chat. Thanks, Mom. Hello from Florida to her and to all the folks watching from the Golden State of California. Been a little quiet on the launch front in California for a minute here. The next mission on the horizon, though, is another NASA-supported flight, the Sentinel-6B spacecraft. With support from the European Space Agency, is set to launch on Sunday, the 16th. Liftoff targeting 9:21 p.m. Pacific. Now that'll be a time to watch and see if that is able to stick where it is. I know I mentioned no politics at the top of the broadcast, but just to touch on something that is relevant to this and other missions coming up for the foreseeable future. While the federal government shutdown has ended and the previously furloughed workers are now largely back at work starting today for those who are able to make it back into the office or place of work today, the FAA and the U.S. Department of Transportation did create a new emergency order that affects the U.S. airspace. And where that's relevant to the launch front is that it extends the time restriction for commercial space launches, keeping that bracket of time between 10 p.m. and 6 a.m. locally for commercial launches. And as we've learned, the commercial aspect of that, even if the payload is that of a fellow branch of the federal government, like NASA, for instance, that doesn't automatically get them exempt from that. So, like with this mission, and quite likely, as we'll see with the Sentinel-6B flight, NASA, and in the case of Sentinel-6B, or in the case of Blue Origin here today, needs to seek permission from the FAA and get an exemption for those launch attempts. That's why you're seeing the Vulcan launch targeting a period of time that begins after 10 p.m. tonight, where their window was earlier previously. And the launches from SpaceX tomorrow also targeting after 10 p.m. Time now T minus 2 hours, 41 minutes, 55 seconds and counting. With the better part of 3 hours still ahead before the opening of the window for Blue Origin today to launch its New Glenn rocket, let's go ahead and take a look at the countdown timeline and talk about the milestones that have already passed and what is still out ahead of the company founded by Jeff Bezos. Fueling process began at about T-minus 4 hours and 30 minutes with the loading of liquid hydrogen on board the rocket's upper stage, referred to by Blue as Glenn Stage 2 or GS2. About half an hour later, both liquid oxygen began flowing on board both the first and second stages of the rocket. And the most recent fueling milestone that began was nearly 50 minutes ago now at this point, when the liquefied natural gas, or liquid methane, began to flow on board Glenn Stage 1. Blue Origin says propellant loading wraps up about an hour prior to flight, and then they stay in mode of topping off those various tanks that I just mentioned. The all-important weather check, which definitely came into play throughout the course of Sunday's launch attempt, happens at around T-minus 20 minutes, though if past as prologue, we likely won't hear the weather briefing coming directly from Blue Origin, but if there's something notable, it may get brought up in due course. T-minus 17 minutes is when the go-no-go poll is conducted. If all the members of the evaluation staff determine that they are good to move forward, then they will proceed towards the terminal count, which is the final 4 minutes before liftoff. The tanks are pressurized at T-minus 2 minutes and 30 seconds. About a minute after that, the vehicle shifts to internal power. The water deluge system is activated at T-minus 30 seconds, and that's when the autopilot for the rocket is also enabled. The 7 BE-4 engines that power Glenn Stage 1 are activated at T-minus 5.6 seconds, and if all goes well, the engines respond as expected. The hold-down clamps will release the New Glenn rocket for a liftoff at T0. Currently, Blue Origin is targeting the opening of the window today. As I was saying a second ago, just double checking that the facts on the ground are still what they are. Blue Origin appears to still be targeting the opening of the window at 2:57 p.m. Eastern, 1957 UTC for our friends joining around the world. Time now T-minus 2 minutes 34, or 2 hours 34 minutes 28 seconds and counting. So far things seem to be progressing well for Blue Origin today. On the weather front, both here locally around our planet and a little bit farther beyond, it's been a bit of a tumultuous week. Of course, we had the scrub on Sunday in part due to the presence of cumulus clouds. That was the ultimate showstopper by the time all was said and done, according to Blue Origin. Then yesterday, the impacts from the 3 coronal mass ejections from the sun created geomagnetic storm conditions that were not favorable to launch, and NASA put the kibosh on things. Today, though, things are looking a fair bit better. Just taking a look at the latest from the NOAA Space Weather Prediction Center. Teams there at the center in Colorado are still tracking the potential presence for G3 strong storm, geomagnetic storms today, dropping down to a G1 minor status by tomorrow, and then no warning level by the 15th. So we'll see how things progress if that becomes a factor by Blue's estimation. But of course, that is something that teams will undoubtedly, both on the Blue Origin as well as on the NASA side, be watching very closely. The 2 spacecraft that are on board were manufactured by Rocket Lab over at their facility in Long Beach, California, where they work on their space systems side of the business, as well as do some work on the Electron rocket. Last year, we had the good fortune of being able to visit that facility and get a tour inside, learn more about the production of their various satellite and spacecraft platforms that they built satellites upon for other customers. Want to bring you inside that facility now with us for part of the tour, where we spoke with Christoph Mandy, one of the engineering leads for Rocket Lab's Space Systems Department. We pick up this part of the tour where he's talking about the propellant tanks, 4 of them that are on each of the ESCAPADE spacecraft, using an example of a model of one, which, as he'll note at the top of his comments, is considerably heavier than the actual flight models that are on board the twin spacecraft named Blue and Gold on board. So this is part of our walkabout, thanks to Rocket Lab. Let's go ahead and take a look.
Just a quick stop, because you won't be able to see them in the clean room. This is an ESCAPADE tank, so there's 4 of these per spacecraft. That PMD device I showed you is down here at the bottom. This is a 3D printed PLA model. It's a plastic thing. It's just a mock-up for us to test MLI, but that's the shape of it overall. It's actually, I've touched the real ones. This is incredibly heavy compared to the real one. The real ones are 6 and a little bit kilos, which is a great achievement for something this size, made of titanium as well. And this feels to me like it's 12. I'm going to try and lift it.
Yes. A bit more actually.
So the reason I showed you this is because I'll have to have you imagine them as they're covered in MLI now, and you won't see them. The concept of a standardized bus is a contentious point in the industry, and even within companies, people have different opinions. But as a baseline, each of these has some pretty different capabilities. So the Explorer product line, which would include the mission we sent to the moon on Capstone or ESCAPADE, have a very, very high mass fraction that is fuel. In the case of ESCAPADE, it's almost 70%, which is an enormous number, and that allows you to do a lot of delta V. So if you are the type of mission that needs a lot of delta V, you'll probably go for Explorer. You can probably kind of tell there are 2 decks, same as on the Varda spacecraft. There's a top deck, which is called the payload deck. On top of the top deck are the instruments. Things from this spacecraft that are closest to you, like the little ball on a stick or the red eyepieces, are those instruments. They came from Berkeley. They built them over there and then shipped them to us. On the underside of that top deck, is where we put most of our avionics, software, computers, radios, amplifiers, all of those things. Then you've got 4 tanks, and then you've got the bottom deck, and the bottom deck primarily has all of our fluidics, so the valves, the regulators, and all the rest. And then underneath that is an engine, and you can probably see the engine bell sticking out from both of them. Well, you can sticking out from this one, from that one, it's been encompassed in what is going on with the spectrum. So, the engine visible is on that one. So that's the overall layout. Many of the components come from Rocket Lab. I mean, we make most of the avionics boxes ourselves. We make the MLI ourselves. The radios are ours. The star trackers are our star trackers. I don't know if solar panels are ours as well. Thank you. And so we, I think Rocket Lab has, in general, done a very good job of deciding two different factors. One is build versus buy, so when it makes sense for us to build versus buy from someone else. And second is when to bring things in-house for vertical integration. The composites is a very good example of this. The fact that we have, the only reason, higher level, many of the requirements came from the launch situation we had. So we were the first Vader mission, which is a rideshare acquisition contract method that NASA came up with, I think 3 years ago. And we were the first spacecraft to go down that line. And the way that is set up is that Vader assesses a bunch of launch vehicles, extracts from that some requirements that are sort of all-encompassing, and then imposes them on the spacecraft. That's the spacecraft view of it. From the launch vehicle side of it, if you're approved under Vader and you're one of the 14 launch vehicles that could be doing it, then you can bid for the contracts when ESCAPADE comes up. And so, getting an all-encompassing set of requirements that covers many, many launch vehicles is actually difficult. It made sense in the context of a low-cost mission that NASA wants to do, but it means that the amount of work we have to do is a little bit bigger than if they have specifically identified a single launch vehicle from the beginning. And the main ones that tend to come up are center of mass and frequency. So you want the center of mass to be as low as possible because you can have a rocket and then your satellite is going to be stuck on the edge of that rocket. It's going to shake about. And the closer that center of mass is to the rocket, the less you're imparting forces onto the rocket, so everybody's happy. The other thing that people care about a lot is the fundamental mode of that satellite. So if the fundamental mode is high enough, then nothing's going to happen. If it's low, then it might interact with the rocket. And so these things need to be high. Those are great constraints, but they're very, very hard to achieve with a spacecraft that is primarily fuel. There's nothing we can do about the fuel. Fuel is going to put the center of mass where the fuel wants to put the center of mass. It's going to have the frequency it wants to have. So it made it pretty difficult to do those things, but we did. And one of the ways we do that is by being very, very smart about our composites. All of the load paths in the composites are kind of complicated and go through things such as inserts. The number of inserts we have in these panels are absolutely insane. There's over 120 in one of them, which is a very big panel that's almost just 1 meter by 1 meter. And then the other thing we've done is panel and panel. So it's not unheard of, but panel and panel composites is not something that every company is capable of. So, those are the kinds of things we did. Another maybe example of smart decision making is the solar panels. You can see they look weird, they're kind of at an angle. The reason for that is because the payload tries to measure electric and magnetic fields. The solar panel is a fantastic source of electric and magnetic fields that could interrupt the payload. So what the spacecraft cares about is to have the solar panels pointed at the sun. It's a great idea. What the payload cares about is to have the solar panels not generate these fields, which means not be pointing at the sun. And the compromise there would typically be that you put motors on those solar panels so that they turn the way you want to. But those things are incredibly expensive and very difficult to make. And so we found a way to not have them on, which massively reduced our cost by making the system a little bit more interesting, which meant having those solar panels at a 40-degree angle compared to the top there. There's a lot of, I'm very excited for my satellites for many reasons, but one of the main ones is that we really did, our design ethos is to have uncompromising efficiency. There's really nothing on the satellite that is extraneous or complicated or needed. And we typically push the capabilities of the technical side in order to find some really good synergies. A good example of that is that deck situation. So, there are many challenges in the system overall, but once you take composites and make them do the absolute extreme, you end up with a spacecraft that looks like this, which is 2 decks with struts separating them. And that means that your entire load path, everything in the satellite goes through either the decks or those struts in between the decks that carry everything. The tanks that are inside see no loads. Any of the other structures on there see no loads. It's all carried by the decks. The contrast to that, just so you can picture it, is a skinned satellite, which is how many satellites are made, where you basically have a box, right? And you put components on the box. Box is another great way of making things stiff, but at a materially bigger mass cost. Now, things change in the industry and it's evolved, but the typical numbers that you give is a primary structure. So the main structure should be on the order of 20 to 25% of the mass of the spacecraft. When we do it our way, ours is 11%. So, pushing composites to extremes allows us to do that. That's cool. But what I really like about our spacecraft is that we then take that and make it do even more. So once you've decided that you've got 2 decks, you can do something really useful, which is you can put all of the hot stuff on the top deck and all of the cold stuff on the bottom deck. All of our avionics, all of our, which emits power, our batteries, which emit power, amplifiers, which are insanely inefficient and always infuriating and emit a lot of heat, they're all on the top deck. And that top deck is cold biased. We try and keep the top deck cold. The bottom deck has all of the fluidics lines. Those are the kind of things that get cold. So, when you expand the gas, stuff freezes. You definitely don't want propellant freezes in line. So the bottom deck tends to have to stay hot. And having 2 decks makes the thermal system way simpler. In a skin satellite, you can have a hot and a cold component next to each other and have to fight it, etc. In this system, now you've simplified the system as well.
And our thanks again to Christophe Mandy with Rocket Lab for an excellent and informative tour of their facilities in Long Beach, California. Currently T-minus 2 hours, 23 minutes, 14 seconds and counting to the planned liftoff of Blue Origin and its New Glenn rocket. Time now T-minus 2 hours, 19 minutes, 55 seconds and counting. Taking a quick look at our live chat here. I want to thank Tim H. for a $5 super chat. Thank you so much for your support, Tim, who says, would have been glorious to see this beast launch at night, but it's a beautiful day for it too. Well, Tim, if you want to see a nighttime launch of New Glenn, you can just wind the clock back and check out our coverage from NG1, which was very much a nighttime launch. So, speaking personally for myself, I'm looking forward to seeing this rocket in the daytime. Have a little bit of contrast between those two experiences. I have no doubt, given the number of missions that are booked and will be booked on a New Glenn rocket, that you'll have plenty of opportunities to see this launch vehicle at all stages of the daytime and the nighttime, as the launch needs may be. Been a busy day for Blue Origin, not only in getting this launch ready here today, but also in some future opportunities that they are working on. Today there was a board meeting for Space Florida, which helps to get various projects both off the ground and look at different funding mechanisms for different companies, investments, and initiatives. And for some of the smaller players, provide some potentially larger capital opportunities, and for some of the more established folks like Blue Origin, some matching funds to help certain expansions and projects come off the ground, especially when it comes to ones that add additional jobs here to the Sunshine State. One of those, as we're looking out at Launch Complex 36, will actually pretty notably change the landscape out here. Just looking back at, this is our view from photographer Adam Bernstein here. Don't have a ton of details on this just yet. We'll poke around and see what we can find out, but Blue Origin did request, and the board did approve earlier today, for an amount of up to $7.8 million to coordinate with FDOT and Blue Origin for the construction of what's being referred to as a vertical integration and refurbishment facility and LC-36 flight rate improvements. Blue Origin, for their part, has committed $196.7 million in total capital investment and has pledged to add 120 jobs in support of this operation. While we haven't heard from Blue directly about this, perhaps it'll be something that they touch on in their broadcast today, though. We'll see. It might be a little too early for them to want to speak out about this with much more detail. But Blue is one of the companies alongside SpaceX and United Launch Alliance that is part of what's referred to as the National Security Space Launch Phase 3 Lane 2 contract. It's a mouthful, but in essence, these are the most demanding and complex missions from the U.S. Space Force, as awarded by the Space Force's Space Systems Command, which manages that contract alongside Assured Access to Space Directorate. For this latest round of contracted missions for national security payloads, SpaceX won the bulk of those, winning roughly 60% of the planned missions under the Phase 3 Lane 2 contract. ULA received about 40% of the current and future allotted missions, and Blue Origin will be tasked with 7 flights under this current contract. One of the aspects that Space Systems Command looks at when considering whether to assign any given mission to either SpaceX or United Launch Alliance or any other future provider that would meet the requirements of Lane 2 style contract with them. Some of those missions require vertical integration, such as United Launch Alliance conducts out at Space Launch Complex 41 here in Florida, as well as at Slick 3 out in Vandenberg, where they are working to bring on the ability to launch their Vulcan rocket, which should be finished by the end of this year, and looking to launch their first mission potentially in 2026 from California with their Vulcan rocket. Of course, both sites support a vertical integration, and it looks like Blue is trying to get some of that possibility for a launch contract task order. So no timeline for their vertical integration and refurbishment facility at LC-36, but worth noting that that is something that they have been pursuing and have secured an amount of up to $7.8 million from Space Florida in matching funds to do some work alongside with Blue and FDOT to make that a reality. Some of the other notable expansions and approvals for Blue Origin that were discussed during today's Space Florida meeting: an agreement to allow for some funds to go to Blue in the amount of $9.25 million. That's in support of, I'll quote them here from their agenda: space hardware assembly, refurbishment, and test processing facilities, expanding its Rocket Park Employment Center in Exploration Park. Blue Origin will expand spaceport capabilities through construction of the hardware assembly and refurbishment facility and test and processing area facility. As part of the project, Blue Origin has committed $38 million in total capital investment and the creation of 175 high-wage jobs, end quote. This work at Rocket Park has already begun. You may have noticed if you've driven along that road heading out towards the Kennedy Space Center Visitor Complex. If you're coming from State Road 3 here in Brevard County and you would pass Blue's campus on the left-hand side of the road, it'll be some of that construction area that you first see when you come around the corner on the left-hand side. That's where they're looking at the expansion in part, getting some more support from Space Florida to further expand on that. time now, T-minus 2 hours, 6 minutes, 45 seconds and counting. During the last attempt where fueling had begun to launch the New Glenn rocket on Sunday the 9th, during the broadcast, one of the pre-produced packages that Blue Origin shared was a conversation with their CEO, Dave Limp, to talk about expectations for this launch and a little bit of an overview of the company and where things currently stand. So as we approach the T-minus 2 hour mark, let's go ahead and listen into these remarks from Blue Origin CEO, Dave Limp.
This is a really big moment for Blue Origin. Can you tell me how NG2 compares to NG1?
Yeah, I think NG1 was obviously our first mission. There was lots to learn, and we did learn a lot, and unbelievably successful in that we made our goal, which was to get to orbit. This time we're going to be a little bit more ambitious, and we want to not only get to orbit, but we have our first paying customer this time with ESCAPADE and get them off to Mars. That's the first part of our goal, and then the second part of the goal is to land the booster out on Jacklyn. And if we don't, we have more over here in the factory that we're building, but we're going to give it our best shot.
And can we talk about kind of how hardware rich we really are right now?
Yeah, the production team has done such good work that even from the last time we chatted, we have, I think, 8 upper stages in work over here. We have a couple sets of engines that we're working on right now, not in addition to the engines that we've shipped over to ULA at this point, and we have multiple boosters in work too. So, the goal is to get to a much faster cadence as we learn each of these flights. So we're going to continue to get faster and as we go along.
Never Tell Me the Odds is pretty fitting for this booster. We are taking our second attempt at landing it for the first time. How are you going to feel if we land it?
Well, I certainly will not channel my inner C-3PO. I will be very ecstatic. I'll be on pins and needles up to that point, but it would be a huge achievement for the team and for Blue. I think that we have a good chance, but if we don't, like I said, we can build more, but I will be over the moon if it happens.
Now, New Glenn is obviously just one of the many systems we have here, right? We have New Shepard, we have Lunar, we have In-Space Systems. How are all of those organizations really working together to further our ultimate goals?
Yeah, I think each component of what we do has a piece of trying to get millions of people to work and live in space, and they all have their individual. But as it relates to this particular mission, a huge amount of people have put work into it. Obviously, our engines team in building both the engines for the booster, the BE-4s, and the BE-3Us for the upper stage. We also have a huge amount of work by the obviously New Glenn team building this vehicle, but also New Shepard has been a pathfinder. So all our avionics fly on New Shepard first so that we can get a sense of what's going on there and get a sense what it's like to have flight-ready hardware. And so it takes a whole team, and it's a very big cross-functional effort across Blue.
We have our motto, right? Gradatum Ferociter. How has that really kind of gotten us to the point where we are today, and how is it going to take us further?
We have a philosophy that if we can test on the ground, we're going to test on the ground, and we're going to try to get things as flight-like as we possibly can. There's some things that we can only test in flight, and G1 was a good example of that. We flew it, we learned a lot, we've made the changes, and now we'll get to fly again. But I think that if we can methodically build, but also do it in a way that we have a decisiveness and urgency, we can really achieve the goal of building the world's best manufacturing company. And that's what it's going to take to sort of be able to drive this audacious mission of getting millions of people into space. And I see the progress every day. When you look out at the factory floor here, or you're in Huntsville, I try to get to all the factories as much as I can. You just start seeing they're beginning to get their feet under them, and they're starting to hum like a factory that's a well-oiled machine.
And this is something that is important to you being at the helm for the past 2 years. You and I got to talk briefly earlier, but you said how important it was for it to function that way, to be manufacturing.
I think anybody can build a prototype of something. I mentioned that to you last time. It's even a prototype rocket you can probably brute force your way through. But building a lot of something, you have to build the machine that makes that machine, and it's a harder task actually. And if you walk a factory, you can tell a factory when it's got a life to it, when it's starting to hum. You can also tell a factory is broken.
Right, you're hearing that hum. And within that, we have more than 10,000 employees here that are very excited about this moment. I'm one of them. What is your message to those who are going to be watching our webcast and be watching NG2 take to the skies?
Well, I think everybody will be a little bit on pins and needles, I'm sure, but I would say that this is a culmination of a lot of work from a lot of teams. It's not the end point of our journey. Obviously, we have a lot more rockets to make and a lot more customers to make happy as we move forward. But to the extent we're successful here, I hope everybody at Team Blue takes a pause, smiles a bit, celebrates, because it'll be a great achievement for us. And we'll take that deep breath, we'll sort of embrace the moment and then move on, because we have a lot of customers waiting for us to succeed. And there's nothing that makes you happier in business and in your life when you see the smile on customers' faces.
I mean, yeah, speaking of that, customer focus is a big part of what we do here. ESCAPADE being our first customer, NASA being our first customer. How do we intend to use what we learn from this launch and to continue to build great relationships with our customers?
Well, I'm super excited about our relationship with NASA. We obviously have it across many parts of our business, including lunar and other places, and having the privilege of getting them on their way to Mars is just so amazing. And I think that this science mission embodies what NASA is great at, which is partnerships and being able to be a little bit more scrappy and do science projects at a price point that hadn't always been able to achieve. So being a little part of that is great. But obviously, as we can get more and more successful getting payloads to orbit, I think that gives confidence for other customers. I've never seen such a high demand for a launch than right now, and so it's great to see, but it means we have to execute and get our cadence of launch higher and higher.
Did you ever think that you would be doing something like this in your career?
No.
You're watching your rockets launch? No?
No, not in a million years. I was very happy making Fire TVs and Echoes, but it is a boyhood dream, and so to be able to have it, I kind of pinch myself every day and just amazed that I get to wake up and help this and lead this amazing team of people build incredible technology like New Glenn.
I mean, and a reference to that, one of the first things they ask you when you come onto Blue Origin is, what is your first memory of space? What is your first memory of space?
Yeah, I have a lot of pictures. It turned out my third, fourth, and fifth birthday, I have these old Polaroids of the cake, and they all have rockets on it. I was enamored with rockets as a kid, and never took the path where I thought I'd be running a rocket or a rocket company, but it turns out that it was very early in my life that I had a lot of love for it.
And we're so grateful to have you here at the helm. Dave, thank you so much for your time. I appreciate it.
Yeah.
Time now, T-minus 1 hour, 58 minutes, 35 seconds and counting. As we're just under the 2-hour mark at this point to the opening of the window, I want to thank the more than 1,600 of you who are watching along with us live today. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream, allowing some more folks to find their way into this live launch coverage. As a reminder, be sure to hit that subscribe button as well, just beneath the video, if you're not already a Spaceflight Now subscriber. It's a quick, easy, and free way to support what we do here at the channel. And if you ring that bell icon and make sure you've got notifications turned on your phone or laptop or whatever device you're watching this live stream on, that way you'll be notified when we start new live streams or post videos to the channel, as we did about the coronal mass ejection impact that prevented the launch of this mission yesterday. It'll also, of course, alert you when we're getting ready to go live ahead of the upcoming launch tonight of ULA's Atlas V rocket, supporting the Viasat 3 F2 mission. Top of the hour here on the East Coast, 1 p.m. Eastern, as Blue Origin is progressing towards the liftoff of its New Glenn rocket from Launch Complex 36. In that video we just played for you, you heard Blue Origin CEO Dave Limp refer to his time working at another Jeff Bezos venture, that being, of course, Amazon. In a bit of a change today, the satellite wing of the Amazon venture, which previously, up till today, has been referred to as the company's Project Kuiper, the constellation of broadband internet satellites that it has been deploying into low Earth orbit this year, with so far a trio of missions on board SpaceX's Falcon 9 rockets, as well as 3 flights using ULA's Atlas V rocket, flying in a 551 configuration. The news today is Project Kuiper is now Amazon LEO. So a bit of different branding, slapping the Amazon name front and center for its constellation. Company says Amazon LEO is, quote, a simple nod to the low Earth orbit satellite constellation that powers our network. Noting that the ultimate initiative of the now former Project Kuiper is still going to be the same under its new branding of Amazon LEO. And of course, there are quite a number of missions supporting the, going to take some adjusting to, the Amazon LEO constellation. Those include 12 booked flights on board the Blue Origin New Glenn rocket, with an option to add an additional 15 flights supporting the Amazon LEO constellation in, appropriately, low Earth orbit. Each of these New Glenn flights supporting the Amazon LEO constellation will be able to fly 61 satellites in one go. That's compared to 45 Amazon LEO satellites on board a Vulcan rocket, up to 27 on an Atlas V, and 24 on a Falcon 9. TBD on how many of the Amazon LEO satellites can fit onto an Ariane 6 rocket, but the tech giant did buy 18 flights through the Ariane 6 launch vehicle. Presumably those launches will begin sometime in 2026, although we don't have a first date specifically named for that mission, or the first flight of previously Project Kuiper, now Amazon LEO, on a New Glenn rocket. Talking trajectory for this mission, which we will do as we progress throughout the countdown here. I'll mention it at least once this hour and again in the next hour. After liftoff from Launch Complex 36, Blue Origin's New Glenn rocket will fly on a largely southeasterly trajectory. And if all goes well, the first stage booster, called Never Tell Me the Odds, will separate from Glenn Stage 2 and target a touchdown on Blue Origin's Jacklyn autonomous landing barge. This vessel is named in honor of Jeff Bezos' mother. That landing pad that you see there at the heart of Jacklyn is the same size as what Blue Origin uses out in West Texas when it lands the booster of its New Shepard rocket, that suborbital vehicle. So far in its road to having a reusable launch vehicle, Blue Origin, I believe at this point, has not said anything specifically on a plan to recover the payload fairings, though that is quite possibly something that they will look at in the future. But for now, fairing recovery is not part of their agenda. Here's another look at the visibility for this mission as created by Blue Origin. This will give you a sense post liftoff of about how far out and at what time intervals those of you who are in this part of the country should be able to see the rocket, assuming obviously good visibility where you are and the lighting conditions. One more graphic for you for the time being, actually the penultimate graphic for now. Here's a look at the flight profile in a flat perspective. Of course, following booster separation and assuming a good touchdown on the Jacklyn barge, they will safe and secure the booster to that landing platform. Then it's about a 4 days journey heading back into Port Canaveral, where the booster will be offloaded, placed in a horizontal configuration, and then brought back over to Rocket Park, where teams will examine their first recovered booster. And the plan as it stands right now, if the vehicle is determined to be flight worthy for at least one more mission, this will be the booster that is intended to launch the company's Blue Moon Mark I robotic cargo lander that will fly a mission for NASA's CLPS program, the Commercial Lunar Payload Services, head to the South Pole. That mission would launch sometime in early 2026 if all goes well and it's a smooth path back into the factory with this booster. But as you heard from Dave Limpin, as others with Blue Origin leadership have said, they do have some number of other boosters in flow right now at the Rocket Park. That would likely be a potentially longer timeline to get back to the pad if they are using a wholly new booster. So the team is certainly hoping that they are able to recover the vessel today, or recover the booster with their Jacklyn vessel today. Here's an overview of their booster recovery operations. I'll pause here so you can take a closer look at this one. Got a lot of folks that are starting to line up at the end of Jetty Park Pier in hopes of getting a good vantage point of this launch here today. Want to address something that came up in the live chat. I mentioned it early in the broadcast, but it's been about an hour and some change since then. We've had some more folks come into the live chat in the interim. Channel member Yazada mentioning that, as those in the United States probably know by now, that the federal government shutdown has ended. And Yazada says, so I expect that the FAA will be going back to its usual launch schedule. Not at the moment. Yesterday, the FAA and the Department of Transportation issued a new emergency order that extends some of the impacts to the busiest airports around the country, but nestled within that emergency order was a clause that addressed commercial space flights, since obviously they very much impact national airspace when they launch. most notably when it's a new rocket like the New Glenn. For now, the FAA is leaving its bracketed time restriction in place, which means that commercial space launch can't move forward outside of the 10 p.m. to 6 a.m. bracket without getting an exemption from the FAA, as Blue Origin did in order to launch this mission for its necessary timeline. As Stephen was reminding me in my ear, and certainly worth noting here, of course, NASA is the primary customer flying aboard this mission, and while Jared Isaacman has been renominated to be the Senate-confirmed NASA administrator, that process has not happened just yet, and so for now, the Transportation Secretary, Sean Duffy, still remains the acting NASA administrator. So perhaps there's a little bit of crossover there when it comes to green lighting NASA-based missions. So I would not be overly surprised to see an exemption to that 10 to 6 a.m. rule when it comes to the launch of the Sentinel-6B spacecraft coming up here soon. Time now, T-minus 1 hour, 42 minutes, 55 seconds and counting. Want to welcome in new channel member David Johnson joining us with membership at the pad leader level. Welcome aboard, David. We're glad to have you with us. Time now T-minus 1 hour, 40 minutes, 17 seconds and counting. As we were just discussing the plans for New Glenn booster recovery, obviously that entails the reuse of the 7 BE4 engines, or as many of them as are able to be reused as possible. That's a big part of Blue Origin's business model, is in a similar fashion to SpaceX, to be able to recover the first stage boosters and fly them multiple times. Right now, Blue Origin's stated plan is for up to 25 flights per booster, though, as SpaceX is currently doing, I have to imagine Blue Origin at some point in the future will want to extend that beyond 25 flights. That's the plan for now, though, but in addition to Blue's reuse of the BE4s, another company that is eyeing reuse of these engines is the other company that's flying them right now, which is United Launch Alliance, whose Vulcan rocket is powered by a pair of those BE4 engines, in addition to up to 6 solid rocket motors provided by Northrop Grumman. Earlier this month, we had the chance to speak with ULA President and CEO Tory Bruno inside one of the largest rocket factories here in the United States, up in Decatur, Alabama, the north end of the state near the Tennessee River. In this part of our conversation, we talked about part of our conversation about reuse, specifically how Blue Origin's plans for reusing their engines on their rocket matters to ULA in their plans for reuse. So let's go ahead and listen to this part of our conversation with Tory Bruno, and you'll hear a voice off camera. That is the voice of one of the local news anchors there, Liz Hurley with WAFF, who joined us along with a reporter from AL.com on this opportunity to step inside the rocket factory. So here's part of our conversation with Tory Bruno.
Yeah, they'll be going first on the flyback version of the reuse on BE4, so we get the benefit of that data. And when we first begin bringing them back and recovering them, they will partner with us to inspect them and recertify them before we put them back on our boosters. There'll be a little bit of a change in where we do the work, so we'll still build the rockets for the first time here. And then when we're recovering engines, we'll probably ship these boosters that you see, short that section so that we can install it in Florida. But the manufacturing, the raw manufacturing, everything stays right here in North Alabama.
Quick correction on setting expectations for that clip. The bit where you hear part of a question from Liz Hurley, that's actually in a video clip that we'll show you tonight that's connected to the launch of the Viasat 3 F2 spacecraft. So look for part of that part of the conversation later in our dedicated launch coverage of that mission. Time now T-minus 1 hour, 34 minutes, 17 seconds and counting. As Blue Origin continues to track towards the opening of today's launch window at 2:57 p.m. Eastern, 1957 UTC. Here's a broad overview of the mission profile as produced by Blue Origin to give a sense of what this mission will look like and some of the notable milestones along the way.
New Glenn lifts off from Launch Complex 36 on Cape Canaveral. 7 BE-4 engines will ignite and propel the rocket upward with over 3.8 million pounds of thrust, or roughly 17,000 kilonewtons. The vehicle will quickly reach supersonic speeds as it climbs through the atmosphere. As the rocket ascends, it will encounter maximum aerodynamic pressure known as max Q at around 40,000 feet or 12 kilometers. This is the point at which the stress on the vehicle is at its highest. Around 3 minutes into the flight, the vehicle will turn off its engines, marking the end of the boost phase. Shortly after, the reusable first stage will separate and begin its journey back to Earth. 2 BE-3U engines on the second stage will ignite and propel it onward into orbit with the payload. The reusable booster reorients in the vacuum of space using its reaction control system. At 220,000 feet or 67 kilometers, it executes an exo-atmospheric deceleration burn using its Center 3 engines. These engines gimbal for maximum control of the booster. This burn slows the vehicle down before re-entering the atmosphere. As it descends, the booster's strakes and fins work together to slow it down and guide it autonomously back to Earth, landing on a vessel at sea. At around 9,000 feet, or just under 3,000 meters, the first stage begins its final landing burn. The 3 middle engines will light for 20 seconds, slowing the vehicle in preparation for the final descent. The 2 outer engines will turn off, and the center engine will execute the final controlled maneuver onto the landing platform. The vessel will return to Cape Canaveral to prepare for its next mission. Meanwhile, in space, the second stage will continue to power the payload towards its final orbit. At around 400,000 feet or 120 kilometers, the payload fairings will jettison. New Glenn will deliver an unprecedented range of payloads. Large satellites, dual payloads, orbital vehicles, large constellation dispensers, even moonlanders destined to establish permanent human presence on the moon. Once it arrives at its insertion location, the payload will separate from New Glenn's second stage.
Just about 1 hour, 30 minutes remaining on the clock before the opening of the window. You may have noticed that little robot that deployed to help save the vehicle there in the Blue Origin animation of the booster landing on Jacklyn. That little robot is called the Recovery Remotely Operated Vehicle, or the ROVE. Once it is deployed following a good booster landing, it provides power, communication, and pneumatic links between the booster and the Jacklyn barge. One hour, 30 minutes on the clock right now. Here's a look at a breakdown as provided by Blue Origin of the New Glenn vehicle. Stands a total height of about 321 feet or 98 meters in height. That's compared to Falcon 9 rocket, which is 70 meters tall. As you can see, Glenn Stage 2 is roughly 86 feet or 26.3 meters in length. Part of that tucked into the inner stage. where, as you can see, those fins that jut out are about 16 feet at the base and extend about 6.5 feet from the body of the rocket. Those BE-3U and BE-4 engines go through a series of tests at various sites around the country before they're integrated onto the rocket. One of the notable places that's involved in the chain is up in Huntsville, Alabama, nicknamed the Rocket City, where a lot of the engineering work happened with von Braun and his team in the heart of the Apollo era. This is a look at Blue Origin's rocket engine factory there in Huntsville, in Exploration Park. Blue Origin delivered the 30th of the BE-4 engines that it sent to United Launch Alliance within the last about 2 weeks or so was when that 30th one arrived, not too far away over in Decatur, which is just down Interstate 565 for those of you who know that part of the state. Crowd starting to build at the edge of the Jetty Park Pier for this third attempt to launch Blue Origin's New Glenn rocket. With less than an hour and a half on the clock, I want to thank the more than 2,500 of you who are watching along with us live today. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream, allowing some more folks to find their way into our live launch coverage. Time now T-minus 1 hour, 15 minutes, 55 seconds and counting. Blue Origin continues to progress towards the opening of their launch window today with a flight of New Glenn set to lift off at present at 2:57 p.m. Eastern, 19:57 UTC. I want to thank one of our channel members, Captain Action, great name, been a member with us now for 6 months at the pad leader level. Appreciate the ongoing support for now half a year strong. Captain Action says, well, thank you for what you do. Clear skies, great view from Tampa. Shout out to the cool people in the chat. Certainly appreciate all you cool cats in the live chat. If you haven't already, you could help us out just by clicking that wonderful like button beneath the video to help there be even more cool people alongside yourselves. With the government shutdown now over, one of the benefits of that is we've got the NASA centers and their various public relations office that are back in action and able to support with various pieces of media, which want to go to one of those now. An overview of the ESCAPADE mission as produced by NASA's Goddard Space Flight Center, the lead NASA center on the science side of the mission. NASA Launch Services program was responsible for coordinating the launch aboard the New Glenn rocket. So just a quick note about this video. This is the music you'll hear underneath it is not the original music from this video, given that we don't know the source of it and it might incur us a copyright strike. So the music has been removed and replaced with what you're about to hear. Here's an overview of NASA's ESCAPADE mission.
Mars, once a warm, watery world with a thick atmosphere. Now, a cold, arid landscape with its atmosphere thinned out. What caused this transformation? Over billions of years, a relentless flow of particles from the sun, the solar wind, has slowly stripped away the Martian atmosphere, causing surface water to evaporate. But how exactly did this happen, and how could it affect future Mars explorers? NASA's new ESCAPADE mission aims to find out. The Escape and Plasma Acceleration and Dynamics Explorers mission is studying the planet's real-time response to the solar wind, helping us understand Mars's climate history using 2 spacecraft in orbit for the first time.
Past missions that we've sent to Mars to understand the interaction of the solar wind with the planet have only been single spacecraft missions. So ESCAPADE gives us what you might call a stereo perspective, 2 different vantage points simultaneously. This will allow us to really make measurements we've never made before and to characterize the system in a way we couldn't characterize it before.
ESCAPADE's twin spacecraft fly in 2 different formations to see how Mars responds to the solar wind in both time and space.
This is the first time that 2 or more spacecraft have worked out a formation in orbit about another planet, in this case Mars.
In the first formation, nicknamed the String of Pearls, the 2 spacecraft chase each other in nearly identical, highly elongated orbits. This allows ESCAPADE to observe rapid changes in the Martian atmosphere caused by sudden variations in the solar wind.
When we have 2 spacecraft crossing those regions in quick succession, we can monitor how those regions vary on timescales as short as 2 minutes up to 30 minutes. Before we had to wait for 4, 5, 6, 7, 8 hours.
In the second formation, the spacecraft have different orbits that are more separated from each other, allowing ESCAPADE to study both the solar wind and the upper atmosphere of Mars simultaneously for the very first time.
We'll have 1 spacecraft in the solar wind so we can measure what's coming in, and then 1 spacecraft closer to Mars. This will help us understand the cause and effect of what's happening when space weather comes to Mars.
ESCAPADE will not only fill gaps in the story of how Mars's atmosphere changed, it will also help us prepare to send human explorers to the Red Planet. For example, ESCAPADE will give scientists more details about Mars's ionosphere, a part of the upper atmosphere that future astronauts will rely on to send radio and navigation signals around the planet.
Understanding how that ionosphere varies will be a really important part of understanding how to correct the distortions in those radio signals that we will need to communicate with each other and to navigate on Mars.
ESCAPADE's work could also help keep future Mars explorers safe.
Atmospheres can provide a shield that protect humans and other assets on the surface from things like solar radiation or intergalactic radiation. So it's important for us to understand how the atmosphere is changing in order for us to know what we have to do to protect humans and other assets we might put on the surface.
In addition to new science, ESCAPADE is pioneering a new way to reach Mars. Previously, spacecraft launching to the Red Planet had to wait years for Earth and Mars to line up. However, ESCAPADE is launching into a unique orbit that loops around a region in space known as L2, roughly 1 million miles away. Then, it'll return and use Earth's gravity to slingshot itself to Mars. This allows ESCAPADE to launch early and wait in space until the two planets are in the right positions. This first-of-its-kind orbit will also make ESCAPADE the only spacecraft to ever pass through a distant part of Earth's magnetotail, before beginning its 10-month cruise to Mars and starting its cutting-edge work there.
NASA's heliophysics fleet is looking at the sun's influence, and with ESCAPADE, we'll now have multi-point measurements at Mars, which will help us have a more comprehensive picture of what's happening throughout the solar system. We need a solar system-wide understanding of space weather in order to protect our technology and our astronauts wherever they go.
Time is now T-minus 1 hour and counting as Blue Origin is looking to fly its second ever New Glenn rocket, supporting NASA's ESCAPADE mission, a pair of spacecraft that are bound for Mars. ESCAPADE stands for Escape and Plasma Acceleration and Dynamics Explorers. These are twin spacecraft that will orbit the red planet in a couple of different orbital planes, gathering data about Mars's magnetosphere and learning how impacts from the sun and its various offputs like coronal mass ejections and other solar winds have caused a degradation of the Martian climate into what was once a watery world into now the more barren red planet that we see today. The science mission for ESCAPADE is set to begin around the summer of 2028, lasting about 11 months in duration. If you're just joining us, you're watching Spaceflight Now's live coverage of this ESCAPADE flight on board a Blue Origin New Glenn rocket. I'm Will Robinson-Smith, reporter with Spaceflight Now. It's very good to have you with us here. We're broadcasting from the Spaceflight Now News Bureau here at the Kennedy Space Center. But as you can see with these various camera views, we've got our photography teams scattered around, making sure we've got all the best angles on this New Glenn rocket. With about 58 minutes remaining on the clock, want to thank the more than 3,600 of you who are watching live with us right now. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream to allow some more folks to find their way into our live coverage today. Want to thank Psychonaut69, one of our channel members, for upgrading membership to the Launch Director level. Really appreciate that, Psychonaut. As a reminder, channel membership comes with a number of perks, including discounts at our online shop, which is shop.spaceflightnow.com. Access to member-only videos here on YouTube. Access to our members-only Discord server. And, of course, the ability to watch all of our live Launch Liftoff moments from here in Florida in 4K. With just about 56.5 minutes remaining on the clock. Worth noting the milestones that are still ahead for Blue Origin. At this point, the propellant load sequence should be complete and teams are in replenishment. Coming up in now less than 30 minutes is going to be the weather check. After the weather check half an hour before the planned liftoff time, the go-no-go pull to proceed into the terminal count will begin at T-minus 17 minutes. Terminal count picks up at T-minus 4 minutes. The tanks on both the first and second stage of New Glenn are pressurized at T-minus 2 minutes and 30 seconds. The vehicle will shift to internal power about a minute after that. The water deluge system activates at T-minus 30 seconds at the same time that the autopilot is engaged. The 7 BE4 engines will ignite at T-minus 5.6 seconds. And if everything is proceeding on track and there are no issues with the rocket or the ground systems, the clamps will release New Glenn for a liftoff, currently set for 2:57 p.m. Eastern, 1957 UTC. If for whatever reason, as Blue Origin gets into that go-no-go poll at the T-minus 17-minute mark, they can, of course, adjust the launch time for today's mission. They have about an 88-minute launch window available to them today. That lasts until 4:25 p.m. Eastern, or 21:25 UTC. Taking a look at our live chat, want to welcome in new channel member Bridget Uhas, joining us with membership at the pad leader level. Welcome aboard, Bridget. We're glad to have you with us. As we get ready to see the flight of this Mars-bound ESCAPADE mission, let's take a look at the mission profile here. We saw the little bit of an overview from NASA's Goddard Space Flight Center. Let's dig into it with a little bit more specificity, shall we? About 33 minutes after liftoff, the two spacecraft will separate roughly 30 seconds apart, so it won't be this simultaneous separation as shown in this animation. 5 minutes after that, the Viasat tech demo will begin, but we're following these two ESCAPADE spacecraft, so let's stick with things here. The vehicles will enter into this loiter orbit around Lagrange point 2. That is the white dot you see there on your screen. They will remain in this loiter orbit for roughly 11 months until the fall of 2026, when they will perform a slingshot maneuver around Earth using a gravity assist to head out towards the red planet. Take about a year to get out there. The gold spacecraft will be the first to arrive, followed by the one named Blue. They'll each perform a Mars insertion burn initially to change their trajectory and enter into a highly elliptical orbit around Mars, as you can see illustrated here in this animation from Advanced Space. Get that insertion burn, and then you can see how the orbit is refined. During their cruise phase, and then, of course, Blue will follow suit, performing a very similar Mars insertion burn. There will be a series of about 8 trajectory correction maneuvers as these spacecraft enter into the orbit and continue to refine things. The insertion burn is about 11 minutes in duration, and it creates an orbit period of about 60 hours. Over time, in phase 4 of the mission, they will begin to reduce their orbit, get a little bit closer consistently to Mars, and begin to enter into the first planned science orbit. As referred to in the video produced by Goddard Space Flight Center, this will be an orbit where they're pretty close together, described as the Ring of Pearls. String of pearls, excuse me, not ring of pearls. It makes a little bit more sense. The string of pearls, where they will follow essentially one after the other, with a distance varying between about 30 minutes apart when they're closest to the red planet. Here's another look at this version of the mission. This part referred to as Science Mission A, when they're in the String of Pearls orbit. This lasts from about June of 2028 until December of that year in Science Mission A, with a periapse altitude of about 160 kilometers and an AWAPS altitude of about 8,400 kilometers. Then they will transition into Science Campaign B, where they have a little bit more of distinct orbits from one another. And this lasts from roughly December of 2028 until May of 2029. And this is the conclusion of the nominal flight for these two spacecraft, which you're getting a little bit of a closer vantage point of in this animated version created by Rocket Lab, the manufacturer of these satellites. Of course, as is the case with all NASA missions, once they've concluded the end of their primary mission, then both mission managers, along with the folks that manage the budget, will take a look to see if they want to do additional work with this specific mission or if they want to adjust the plans for these two spacecraft beyond 2029. Just about 48.5 minutes to go before the planned launch of the New Glenn rocket. You can see folks are really starting to pack things out there at the edge of the Jetty Park Pier, trying to get the best possible view of this 98-meter tall rocket once it lifts off from the pad. As you take a look at a rotating view of the spacecraft, you can see some of the science instruments that are on board. As we heard from Christoph Mandy at the beginning of the broadcast, those are positioned at the top of the spacecraft. Away from the thruster there down at the bottom. Both of the ESCAPADE spacecraft, while one is named Blue and one is named Gold, they are essentially identical and have the same science instruments on board. One of those is the EMAG, or the ESCAPADE magnetometer, which is positioned at the end of the boom that you saw extending from the vehicle there in that rotating animation. This is from NASA's Goddard Space Flight Center, and the EMAG, I'll quote them here, quote, measures Mars's magnetic field with a range of up to 2,000 nanotesla and an accuracy of 0.5 nanotesla. It's mounted at the end of a 2-meter-long boom alongside a segment of the ESCAPADE Langmuir probe, which we'll go to here in just a second, to minimize spacecraft interference. Magnetometer has a mass of about 0.45 kilograms and uses about 1.3 watts of power. Returns data at a rate of 21.5 bits per second, capturing the ambient magnetic field in various plasma regions encountered during orbit around Mars, end quote. Going back to this animation here for just a second, the next instrument we're going to be looking at is the bit that is right now on the far side of the top. You see that little sort of gold-plated looking instrument there at the top of the spacecraft. That is the EESA, or the ESCAPADE Electrostatic Analyzer. Jumping ahead, here's a closer-up view of that. This science instrument designed to measure the suprathermal ions and the electrons in the spacecraft's elliptical orbits around Mars. Finally, we mentioned the Langmuir probe. Here's a closer look at what that looks like, otherwise referred to as the ELP suite. This comes from Embry-Riddle Aeronautical University. It's got 3 types of probes: the planar ions probe, or the PIPS, multi-needle Langmuir probe, or the MNLP, and a floating potential probe, the FPP. These are designed to measure the integrated extreme ultraviolet flux and thermal plasma density in the solar wind plasma from the elliptical ESCAPADE orbit. There are also a couple of cameras on board the ESCAPADE spacecraft named Visions. These are visible and infrared cameras. The ESCAPADE team, in addition to all the other science data that they're capturing from the other instruments, are hoping to capture things like Mars's auroras. For those in the northern hemisphere, we were treated to a couple of nights of some really nice aurora views thanks to the impacts of those 3 coronal mass ejections that were burst out from the sun on Sunday and made their way to Earth in the following days on the 11th and the 12th. It was actually for that reason that the New Glenn mission was unable to launch yesterday, which is why we're here today. One more graphic to show you for the time being, actually 2 more here. I mentioned those 2 different science orbits for Campaign A and Campaign B. This will give you a side-by-side comparison of what those 2 look like in relation to the red planet. Here's a visual 3D model of those. Here's another way to look at them with their various proximities to the red planet. Time now, T-minus 41 minutes, 34 seconds and counting. Now that we've given you a broad overview of the pathway of these ESCAPADE spacecraft from the pad to the red planet and the mission that they'll be undertaking with their various science instruments, let's hear now a little bit from the principal investigator of this mission. Robert Lillis is representing the University of California at Berkeley. In this clip from a pre-launch conversation, he discusses the reason for the mission and the potential benefits of the roughly year-long delay that these satellites have encountered by not being able to fly on the first launch of a Blue Origin New Glenn rocket. Now that paves the way for future Martian exploration. So here is Robert Lillis, the principal investigator for NASA's ESCAPADE mission.
We're also excited because ESCAPADE is pursuing a very unusual trajectory in getting to Mars. We're launching outside the typical Hohmann transfer windows, which occurs every 25 or 26 months. And so we are using a very flexible mission design approach where we go into a loiter orbit around Earth in order to sort of wait then Mars are lined up correctly in November of next year to go to Mars. And this is an exciting and flexible way to get to Mars, because in future, if we'd like to send hundreds of spacecraft to Mars at once, it'd be difficult to do that from just the launch pads we have on Earth within that month, but we could potentially queue up spacecraft using the approach that ESCAPADE is pioneering. That's exciting. But I'm also very excited for the science. That's why I got into this game. That's why we proposed ESCAPADE, because we really, really want to understand the interaction of the solar wind with Mars better than we do now. We know that atmospheric escape from Mars is a major driver for the evolution of the Martian climate. We know that Mars at least was episodically warm and wet for a couple billion years, but hasn't been so for about 2 billion years or so. And we think atmospheric escape is a major reason for that. And ESCAPADE is going to bring an unprecedented stereo viewpoint, because we're going to have 2 spacecraft at the same time. And that's important because when you only have a single orbiter, you can think of that orbiter as kind of like a weather buoy. You have to be in the place where the conditions need to be monitored. If you only have one spacecraft, you can either measure what the sun is throwing at Mars, the so-called space weather environment upstream of Mars, or you can measure the conditions close to Mars in its upper atmosphere where the atmosphere is escaping. But you can't be in 2 places at once. But we can, because we have 2 spacecraft to do this. So we can really get that cause and effect at the same time. We've never had that before, and that's really exciting. And the last reason why it's also very relevant, we think, this kind of science at Mars, is because we need to understand the space weather environment at Mars in order to better forecast space weather conditions that can cause hazards for future robotic and human explorers, both in terms of the radiation environment that happens when you get a coronal mass ejection or other interplanetary shocks, or the distortions to radio signals as they pass through the ionosphere of Mars. If we understand the variability of the ionosphere better, we can help future explorers to both communicate and also navigate better on the surface. So we're really excited.
And again, that was Robert Lillis, the principal investigator for the ESCAPADE mission. Currently T-minus 37 minutes, 35 seconds and counting. As you can see with this wide view down at the beach, taking a look at some other vantage points here. You can see the weather is pretty nice. Good old Chamber of Commerce kind of day, if you will. And that's reflected in the forecast issued by the 45th Weather Squadron. Meteorologists forecast a greater than 95% chance for favorable weather. Time now, T-minus 30 minutes and counting. Just a half an hour left before the planned liftoff of this New Glenn rocket from Launch Complex 36. At this point, the items remaining in the count right now, teams are going through the final pre-launch weather check as currently planned. About 10 minutes from now, we should also get some pad level views of the New Glenn rocket, courtesy of Blue Origin. T-minus 17 minutes, they'll conduct the go, no-go poll to proceed into the terminal count, which will begin at T-minus 4 minutes. T-minus 2 minutes 30 seconds is when the tanks pressurize ahead of flight, and the vehicle shifts to internal power about a minute after that. In the final 30 seconds, the water deluge system will activate. The vehicle will switch into its automated mode. The 7 BE-4 engines at the base of Glenn Stage 1 will ignite at T-minus 5.6 seconds, and if all proceeds well, we'll see a liftoff of this rocket, the second New Glenn to take flight from the Space Coast at 2:57 p.m. Eastern, 1957 UTC. With less than 29 minutes remaining on the clock, certainly want to thank the more than 7,500 of you who are along with us for this journey today live. If you haven't already, be sure to click that like button down below. Share this video so that others can find their way into this live launch coverage in the final minutes we have remaining. About 28 and a half of them at this point in time. Now, after liftoff, the first and second stages of this two-stage rocket will separate at about T-plus 3 minutes and 9 seconds into the mission. And as we've seen quite a few times now with SpaceX, Blue Origin 2 will attempt to perform a propulsive landing of the first stage booster on an autonomous recovery vessel. Blue Origin has named theirs Jacklyn in honor of Blue Origin founder Jeff Bezos' mother. During the first launch attempt on Sunday, November 9th, Blue Origin shared a little bit of a behind-the-scenes look at the operation of Jacklyn with some of the folks that help operate it. Let's go ahead and learn a little bit more about the barge that, hopefully, about 9 minutes after liftoff, will be supporting its very first New Glenn first stage.
The Jacklyn is the landing platform vessel where New Glenn will come down, land, and we secure it and bring it back in.
She's 380 foot long, 150 foot wide, and she's a self-propelled vessel. We are the recovery side of the operation. This is where GS1 is going to land, and actually that feather is a center point.
We have to leave 4 days before launch. We check all our equipment, and we ensure that everything is working, everything is fully functional. We transit for 300 to 400 miles, depending on how far the landing location is. And once we get there, dynamic positioning allows the thrusters on board here will hold this in position within a range of about 10 feet.
We'll have a couple small changes of Jacklyn's position. They're going to feed us new coordinates, right? So we might move 500 yards this direction, a little that way, but we're generally in the area. And right up to like 45 minutes or an hour before, that's our final position.
When the booster lands, the ROV will come out. Once it's mated with the booster effectively, we'll start pumping high pressure nitrogen into the booster, which will allow the detanking process to continue to make the booster inert and safe for us to operate around.
These are the transit stands. These are what we actually use to secure GS1 to the deck. Each one of these units is individually controlled. We'll have 6 different operators operating them out under the vehicle. And then we're able to lock out the stands, which basically rigidizes GS1 to the LPV deck and allows us to bring it home.
The complexity of what we do out here is pretty important because we operate in such an isolated environment. We're hundreds of miles offshore. We're relying on satellite communication.
The one thing about working on the ocean and in the elements, we fight it. It never wants to work with you. The best you can do is just get along with it. I hope people understand how important reusability is to this program. Us being out here and allowing us to retrieve these vehicles and bring back and reuse them, we reduce the cost, we reduce pollution,
My favorite part of being Team Blue is how everybody works together as a very cohesive group. This is really, really rewarding just to kind of see everyone marching together towards one successful landing operation.
Just about 24 minutes and some change remaining before the liftoff of New Glenn. As we just learned about the recovery operations, let's take a look at the path New Glenn will take to get to where Jacklyn is currently positioned. Talking some trajectory here, the New Glenn rocket will lift off from Launch Complex 36 at Cape Canaveral Space Force Station. It will fly on a roughly southeasterly trajectory, with the first and second stages separating a little bit more than 3 minutes into flight. And as we just learned, it will target a touchdown on the Jacklyn barge. You can see a photo of Jacklyn at Port Canaveral. That point that you're seeing in the little graphic there is where the boosters will be offloaded after a successful recovery. They'll be laid in a horizontal configuration where they will be brought over to Rocket Park, designed to be refurbished and turned around for, as Blue Origin is currently estimating, up to 25 flights at this point. Blue Origin plans, if it has a successful recovery today, to fly that booster again, the booster flying on this mission called Never Tell Me the Odds. It'll be used on the third flight of a New Glenn rocket in support of the launch of one of their Blue Moon Mark I cargo lunar landers. Here's a look at the flight trajectory and the potential visibility for folks that are in the area of the Space Coast and beyond. Now, obviously, this visibility will be depending on where you are locally, the lighting at the time of liftoff, all those typical things with a launch. Time now, T-minus 21 minutes, 37 seconds and counting. We should be getting some video coming in shortly from Blue Origin, but in the meantime, I want to thank a few more folks for their support this afternoon. Big thanks to channel member Chuck Close for a very generous $25 super chat. Thank you, Chuck. Good to see you as always, sir. Also want to thank Cindy Price for a $5 super chat. Thank you, Cindy. Also thanks to Steve C for a $10 super chat. And Virginia Pruitt, one of our channel members, for a $10 super chat as well. Appreciate you, Virginia. Earlier in the broadcast, we talked about some of the infrastructure improvements that Blue Origin is working on in coordination with some financing from Space Florida, which was approved earlier today. Another one of those projects concerns where the boosters will be offloaded. That is North Cargo Berth 8 and the access to that on State Road 401. Earlier today, there was a vote to allow Space Florida to approve of an agreement with the Florida Department of Transportation and Blue Origin to reallocate some funding that was previously earmarked by Blue Origin for the Economic Development Transportation Project Fund. roughly $673,000, and that will help in the design and construction of access improvements at the North Cargo Berth 8 and State Road 4, which will help not only Blue Origin in the offloading and transportation of its boosters, but also potential future customers that need to bring cargo back in through the port. Time now T minus 18 minutes, 30 seconds in counting. As we're approaching the point in the countdown where Blue Origin should conduct their go, no, go poll, just about a minute from now, let's do a quick run through of the launch timeline for today's mission. Following liftoff, the rocket will pass through max Q at the point of greatest aerodynamic pressure on the vehicle at about T plus 1 minute 35 seconds. First stage main engine cutoff happens just past the 3-minute mark. That's followed by stage separation and then the ignition of the 7 BE4 engines at the base of the booster. The payload fairings currently encapsulating the 2 ESCAPADE spacecraft will be jettisoned just before the 4-minute mark in flight. The first stage entry burn, which is roughly 30 seconds in duration, begins at T plus 6 minutes and 48 seconds, followed by the landing burn sequence. And if all goes well with that and the engines ignite as expected and conduct the burns as Blue Origin has planned, we'll see a touchdown on the Jacklyn barge at T plus 9 minutes and 9 seconds. There will then be a cutoff of the 2 BE3U engines on Glenn Stage 2 at about T plus 12 minutes and 53 seconds. There will be a coast phase until 25 minutes into flight. The engines will cut off. The ESCAPADE spacecraft will separate just past the 33-minute mark in flight. The Viasat demo will turn on, and the mission will end about after that.
RC is go. ESR.
ESR go.
AC.
AC is go.
Recovery.
Recovery is go.
PLI.
PLI is go.
BMD.
BMD is go.
GC, LC1, LC2, initiate final configurations for terminal count. Report when ready for pre-terminal count gate checks.
GC cut. LC2 copies. LC1 copy. LC1 ready.
All right, you heard it there.
As you just heard, the teams have polled go as we're about 15 minutes away from the planned liftoff of NG-2, the second flight of a Blue Origin New Glenn rocket. Terminal count will begin at T-minus 4 minutes, so in about 10-ish minutes from now. T-minus 11 minutes, 53 seconds and counting. As the teams pulled go to proceed into the terminal count, worth noting the reason that they scrubbed yesterday and were unable to launch was because of interference from solar activity and those 3 coronal mass ejections that departed the sun and made their way towards Earth by midweek. The 45th Weather Squadron in their forecast for today did also cite solar activity as a high risk criteria for today's mission. That forecast was issued yesterday, so potentially things have calmed down enough today that teams feel like they're in a good position to proceed with the liftoff here, and now just under 11 minutes. Other bit of good news, as I mentioned earlier in the broadcast, the liftoff conditions are greater than 95% favorable for flight. The offshore landing weather is also listed as a low criteria, or low risk, to this mission. So sea state sounds like it's in a pretty good position for the reception of the booster named Never Tell Me the Odds. About 9 minutes after liftoff is when that booster is projected to touch down. During New Glenn's first flight back in January, teams were unable to relight the 7 BE4 engines or the 3 out of 7 BE4 engines as planned, and had to forego a booster recovery with that booster called So You're Telling Me There's a Chance. Time now, T-minus 7 minutes, 4 seconds, and counting. Just want to lay the table for folks with a little bit of a discrepancy we may encounter during the launch of this mission. Teams are currently counting down towards a liftoff at 2:57 p.m. Eastern, 1957 UTC, right at the opening of that minute, or the beginning of that minute, so 0 seconds. The reason I bring that up right now is because what we're getting from Blue Origin, the broadcast here, is behind by roughly 25-ish seconds or so. So at liftoff, we may not be able to show you some of the up-close video of booster ignition because it'll be pretty far off from what our tracking cameras are able to see, and we want to bring you what's happening in real time as it's happening. Just under 5 minutes now to the planned liftoff of this 98-meter tall rocket you see standing at Launch Complex 36. Teams are preparing to enter into their terminal count at T-minus 4 minutes. And again, because of the discrepancy between what we're getting from this Blue Origin broadcast and what's going on in real time, we won't actually hear the terminal count call as our countdown clock reaches 4 minutes. It'll happen about half a minute after that. So again, just to set expectations for how things are going to be flowing here in the next few minutes. T-minus 4 minutes and counting. Teams should now be in the terminal count. We're standing by for that call out here. Let's listen in momentarily.
Steps before launch, and we inch towards terminal count. Let's listen.
T-minus 3:59.
TCS active. AFSA safety timer started.
AFSS safety timer started.
News for you. We are in terminal count.
Time now, T-minus 2 minutes, 15 seconds and counting. The tank should be pressurized now. The vehicle will switch to internal power in roughly 30 seconds. 2 minutes and counting. Now T-minus 1 minute 30 seconds. Vehicle should be switching to internal power. Water deluge system will activate in less than 1 minute. T-minus 1 minute and counting. Vehicle confirmed to be on internal power. Roughly 20 seconds till the water deluge system activates. "40 seconds.
AFSS flight enabled.
30 seconds. Water deluge should be activated. 15 seconds. 10, 9, 8, 7, 2. Not seeing the water. We're in a hold. We didn't see the water system activate. We're standing by for further.
All right, as we've seen here, our team has decided to go into a hold at T-minus 20 seconds. Let's wait to learn just a little bit more here.
Auto-safing complete.
Thank you again, everybody. If you're just joining us, we are awaiting here NG2, the second mission of New Glenn. We are at T-minus 20 seconds. Our team has decided to enter a hold here. We've said it on other webcasts before. We spend years designing this rocket, months building it, months designing the missions. If we need a couple of minutes to make sure that the rocket is ready, that our team is ready, that everything on the range is ready.
That's right.
Then we will take that time.
At this moment in time, I do have a statement that says that terminal count abort. The team is currently investigating. Right now, you've got to look inside of GS2. You can see our twin satellites. I believe that's ESCAPADE, correct?
That is ESCAPADE. They're ready for its launch to space, to Mars. It's going to have to wait just a couple more minutes here, obviously. There you see the base of the rocket, the 7 BE-4 engines.
And as you've been hearing and are seeing now, Blue Origin currently in an unplanned hold. The launch commentators noting that their time stopped at about T-minus 20 seconds, which is about 10 seconds after the water deluge system is scheduled to activate per the Blue Origin timeline. Local time now, 3 p.m. Eastern. As you just heard, the Blue Origin launch team have entered into an unplanned hold. Commentators noting that it began at T-minus 20 seconds, though the timeline of operations state that the water deluge system is supposed to activate at T-minus 30 seconds, and we did not see that begin. Blue Origin does have a roughly 88-minute launch window today that extends out to 4:25 p.m. Eastern, 21:25 UTC. So depending on the issue that triggered the hold, teams do have the opportunity to still launch today. That is not a foregone conclusion of how this day may turn out. If you recall, as Blue Origin was testing this rocket in a static fire, there was just a brief engine ignition after the water deluge system had activated, and teams were able to recycle. Oh, there's a live look at the Jacklyn barge out to the east of the Bahamas, waiting for, hopefully, the booster, never telling the odds, to land about 9 minutes after a liftoff. Anyway, going back to the static fire campaign, teams were able to recycle and conduct a full duration burn of the booster as intended. It was a little bit longer of a static fire than the one ahead of the first flight of a New Glenn rocket. Blue Origin noted that the reason for that is because they wanted to put some extra time on the BE-4 engines to make sure that they were ready to support the necessary entry and landing burns to complete their flight profile and hopefully have a successful touchdown on that Jacklyn barge that we just saw. Right now you're looking at the inner stage of the vehicle that separates the upper stage from the lower stage. It's where the engine nozzles of the BE-3U engines are located. See some ice popping off there from the booster. Another look from a different camera on the Jacklyn barge. This is a nice wide-angle, almost fisheye lens, so assuming a good landing attempt is made, Blue Origin should be able to provide some really nice varied shots of the touchdown of this booster if all goes well. Again, for those of you who may just be joining, as I see we've got now a little more than 28,000 of you with us live. Currently, Blue Origin is in an unplanned hold as teams were less than a minute from the planned liftoff, and the water deluge system did not activate as expected. Teams are assessing the path forward for today, and once a new launch time, a new T0 is established, we will of course bring that information to you as immediately as we possibly can. Local time is 3:09 p.m. Eastern, 20:09 UTC. As a reminder, Blue Origin's launch window today extends out to 4:25 p.m. Eastern, or 21:25 UTC. At this point, Blue Origin has not provided any more information about the cause of the hold that was initiated at T-minus 20 seconds. We'll, of course, continue to monitor that and bring you updates as they emerge. But for the time being, let's go ahead and take a look at this overview of the ESCAPADE mission as provided by NASA's Goddard Space Flight Center, the lead NASA center for this mission. Let's go ahead and check this out as we await for further information from Blue Origin.
Mars, once a warm, watery world with a thick atmosphere. Now, a cold, arid landscape with its atmosphere thinned out. What caused this transformation? Over billions of years, a relentless flow of particles from the sun, the solar wind, has slowly stripped away the Martian atmosphere, causing surface water to evaporate. But how exactly did this happen, and how could it affect future Mars explorers? NASA's new ESCAPADE mission aims to find out. The Escape and Plasma Acceleration and Dynamics Explorers mission is studying the planet's real-time response to the solar wind, helping us understand Mars's climate history using 2 spacecraft in orbit for the first time.
Past missions that we've sent to Mars to understand the interaction of the solar wind with the planet have only been single spacecraft missions. So ESCAPADE gives us what you might call a stereo perspective, 2 different vantage points simultaneously. This will allow us to really make measurements we've never made before and to characterize the system in a way we couldn't characterize it before.
ESCAPADE's twin spacecraft fly in 2 different formations to see how Mars responds to the solar wind in both time and space.
This is the first time that 2 or more spacecraft have worked out a formation in orbit about another planet, in this case Mars.
In the first formation, nicknamed the String of Pearls, the 2 spacecraft chase each other in nearly identical, highly elongated orbits. This allows ESCAPADE to observe rapid changes in the Martian atmosphere caused by sudden variations in the solar wind.
When we have 2 spacecraft crossing those regions in quick succession, we can monitor how those regions vary on timescales as short as 2 minutes up to 30 minutes. Before we had to wait for 4, 5, 6, 7, 8 hours.
In the second formation, the spacecraft have different orbits that are more separated from each other, allowing ESCAPADE to study both the solar wind and the upper atmosphere of Mars simultaneously for the very first time.
We'll have 1 spacecraft in the solar wind so we can measure what's coming in, and then 1 spacecraft closer to Mars. This will help us understand the cause and effect of what's happening when space weather comes to Mars.
ESCAPADE will not only fill gaps in the story of how Mars's atmosphere changed, it will also help us prepare to send human explorers to the Red Planet. For example, ESCAPADE will give scientists more details about Mars's ionosphere, a part of the upper atmosphere that future astronauts will rely on to send radio and navigation signals around the planet.
Understanding how that ionosphere varies will be a really important part of understanding how to correct the distortions in those radio signals that we will need to communicate with each other and to navigate on Mars.
ESCAPADE's work could also help keep future Mars explorers safe.
Atmospheres can provide a shield that protect humans and other assets on the surface from things like solar radiation or intergalactic radiation. So it's important for us to understand how the atmosphere is changing in order for us to know what we have to do to protect humans and other assets we might put on the surface.
In addition to new science, ESCAPADE is pioneering a new way to reach Mars. Previously, spacecraft launching to the Red Planet had to wait years for Earth and Mars to line up. However, ESCAPADE is launching into a unique orbit that loops around a region in space known as L2, roughly 1 million miles away. Then, it'll return and use Earth's gravity to slingshot itself to Mars. This allows ESCAPADE to launch early and wait in space until the two planets are in the right positions. This first-of-its-kind orbit will also make ESCAPADE the only spacecraft to ever pass through a distant part of Earth's magnetotail, before beginning its 10-month cruise to Mars and starting its cutting-edge work there.
NASA's heliophysics fleet is looking at the sun's influence, and with ESCAPADE, we'll now have multi-point measurements at Mars, which will help us have a more comprehensive picture of what's happening throughout the solar system. We need a solar system-wide understanding of space weather in order to protect our technology and our astronauts wherever they go.
A nice view of a paraglider there at the Jetty Park Pier. As you can see, the countdown clock has picked up. Blue Origin appears to be targeting a new T0 of 3:45 p.m. Eastern, 2045 UTC. No word at this point, though, on the reasoning for the hold that happened at T-minus 20 seconds. But this does appear to be our new planned liftoff time. Time now T-minus 26 minutes and counting. For those of you who may just be joining us, Blue Origin has put out a new T0 liftoff time of 3:45 p.m. Eastern, 2045 UTC. Blue Origin does have a launch window that extends out to 4:25 p.m. Eastern, 2125 UTC. So if they are not satisfied with the troubleshooting that's able to be accomplished heading towards this current T0, they do have some additional time to troubleshoot for a launch attempt today. What we'll be watching for coming up here is at T-minus 17 minutes. Presumably they will conduct another readiness poll to enter into the terminal count. And that'll be a good assessment of whether teams are able to progress to the current launch time of 3:45 p.m. Eastern, or if they need more time to work things out today. In the meantime, I want to thank a few folks in the live chat who are supporting us in our coverage today. Our thanks to JB Boating for a $5 super chat. Thank you, JB. Thanks as well to K2 Hat for a super chat, saying thanks again to all those who work so hard. Certainly appreciate your everyday math tutor for the super chat as well. Skunk Hogger PS4, one of our channel members, saying thanks for these excellent streams. Try and catch everyone or on demand. And yeah, if you're not able to be with us live for a launch, no worries. You can always hit that button that saves it to the watch later option and check us out at your own timeline. Thanks again for another super chat from K2 Hat, saying many thanks to the mods and all who help with this coverage. That was as we were still in the hold, which at this point has cleared. Also want to thank channel member Daniel H. for gifting 3 Spaceflight Now memberships. Really appreciate that generosity, Daniel. Thank you so much. And to our 3 newest gifted members, welcome aboard. We're glad to have you with us. If you haven't already, be sure to thank Daniel in the live chat, and we hope you decide to stick around with channel membership. See, we've got folks checking in from all over the place this afternoon. Channel member Anita Brokens joining us from Maryland. Jason Wilkinson checking in from North Florida. Let us know where you're watching from today, whether you're here along Florida's Space Coast or further flung in the United States or perhaps on the other side of the globe. Always great to see where our global audience is joining us from. Looks like we've got the UK to Wisconsin, Nebraska, Daytona. I just saw Algeria. That's cool. Got Ryan R. checking in from my hometown of Sacramento, California. Good to see the 916 in the house. Time currently T-minus 21 minutes, 27 seconds and counting. Certainly appreciate our launch team who's been working hard to make sure that we can bring you all the best views in the pre-launch timeline, and hopefully we'll have a liftoff here in about 21 or so minutes. You're looking right now at one of the cameras from Pete Karstens with Max Q Productions. We're joined as well today by our friends Chuck and Jen Briggs with C&J Images. Of course, our photographers are out and about, working to get their best angles on the rocket once it does take flight. If you're not following our photographers, you can find them at their handles here on X. If the rocket is able to fly today, they'll have some excellent photography for you to check out. So now is a great time to make sure that you are following them. You can also find us at Spaceflight Now by simply searching for Spaceflight Now. We're also on Blue Sky, Threads, and Facebook if you yourself are not on X. "20 minutes and counting." Time now T-minus 17 minutes, 10 seconds and counting. Blue Origin commentators noting that there will in fact be another readiness poll coming up here in the next minute or so. We'll bring in that audio once it begins. Local time now 3:28 p.m. The readiness poll should be underway now, but it looks like the clock may be in another hold, stopping at about T-minus 17 minutes 4 seconds. We're standing by for further updates if a new T0 is Once again, if you're just joining us, Blue Origin back in another unplanned hold, unfortunately. Standing by for any further details on the reason for this hold or when it might be able to be lifted. The hold began at T-minus 17 minutes and 4 seconds. This was just before a readiness poll was set to be conducted, confirming that they were able to head into the terminal count, which would pick up at T-minus 4 minutes. As mentioned before, but worth repeating, Blue Origin's launch window today can extend out to 4:25 p.m. Eastern or 21:25 UTC. So this is certainly not the end of the road today. We're awaiting a status update on the next T0 opportunity for Blue Origin and hopefully some more information on why the hold was put in place this time. Local time, 3:33 p.m. Eastern, 20:33 UTC. Still hoping to learn more about the reason for the hold this go around. Not getting an update just yet from Blue Origin, but we hope to shortly. As well as a new T0. In the meantime, though, we mentioned today was poised to be a double header. Things are progressing over across Cape Canaveral Space Force Station at Space Launch Complex 41, where United Launch Alliance has begun the countdown for their Atlas V rocket. Within the last couple of minutes, the latest from their launch team is that the Atlas booster and the Centaur upper stage have been powered up to begin today's testing and final preps before the fueling campaign begins. Right now, ULA reports that they are conducting first stage propulsion, pneumatic, and hydraulic preps, and final preparation for the Centaur liquid oxygen and hydrogen systems. Quote, all is going smoothly in the countdown for liftoff in just over 6.5 hours, end quote. That mission will carry the Viasat 3 Flight 2 communications satellite and send it on its way to a geosynchronous transfer orbit. You can read more about the mission to launch that roughly 6-ton vehicle. That's up on our website right now, spaceflightnow.com. I point you in that direction since this obviously is not the dedicated coverage for that mission, but since we're now at a point in the countdown where we have two intersecting countdowns here at Cape Canaveral, just worth noting, especially since we're in an unplanned hold with this New Glenn rocket, letting you know where things stand across the Cape. as we're still waiting for further, want to thank a few folks in the live chat here today for your support. Big thanks to Levi Brostfield for a $2 super chat. Thank you, Levi. The countdown clock is moving again. We're adjusting and bringing our clock back into alignment here. Stand by. Now looking at 3:55 p.m. Eastern. Expecting another readiness poll to happen at about T-minus 17 minutes. Again, because the feed coming in from Blue Origin is slightly off real time, it'll be a little bit past when you see the countdown clock in the upper right-hand corner of the screen reach the 17-minute mark. "17 minutes and counting. Standing by for the readiness poll." Time now currently T-minus 15 minutes, 30 seconds and counting. We did not hear the readiness poll, but one of the Blue Origin commentators is reporting that teams have polled go to proceed towards the terminal count once again. Just under 15 minutes now. Roughly 11 minutes away from entering into that terminal count. For those of you who may just be joining us, we are now 13 minutes away from the planned launch of Blue Origin's second New Glenn rocket. Liftoff time is 3:55 p.m. Eastern, 20:55 UTC for those of you joining around the world. It's about 30 minutes before the end of today's launch window. If, for whatever reason, Blue Origin needs more time beyond the current planned T0. Certainly want to thank the more than 25,000 of you who are sticking it out with us here, as we're just about quarter till top of the hour here. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream. Also, be sure to subscribe to the channel if you haven't already. That's a great way to support what we do here at Spaceflight Now, and that way you'll be notified when we begin new broadcasts, as we will once again later on tonight ahead of the planned flight of United Launch Alliance's Atlas V rocket. Time now T-minus 10 minutes, 33 seconds and counting. As a reminder of the milestones still ahead before liftoff of this rocket, as we expect to see them. The terminal count will pick up at T-minus 4 minutes. The tanks on New Glenn pressurize at T-minus 2 minutes and 30 seconds. The vehicle shifts to internal power a minute after that. What we didn't see last time is certainly what we hope to see this time, is the activation of the water deluge system at T-minus 30 seconds. The system's autopilot will engage at T-minus 30 seconds as well. The engine ignition sequence begins at T-minus 5.6 seconds. And if all goes well at that point, the 7 BE4 engines are healthy and ignite and operate as expected. The hold down clamps will release New Glenn for liftoff. Once again, currently targeting that departure right now at 3:55 p.m. Eastern, 20:55 UTC. 8 minutes and counting. Want to welcome in new channel members John Ramsey joining us at the pad leader level along with Swan CD. Welcome aboard. We're glad to have you with us. As we're getting ready to see this rocket lift off from the pad, hopefully in just about 7.5 minutes, let's give you an animated overview of what we expect to see post liftoff. This animation is a little bit of an abridged look at the launch, but assuming everything goes well at T0, we'll see the departure of New Glenn, similar to this one there that you see live at the pad on the right-hand side of your screen. About 1 minute and 35 seconds after the departure from Launch Complex 36, the rocket will pass through max Q with a point of greatest aerodynamic pressure on the vehicle. There's a few events in fairly rapid succession. At the 3 minute 5 second mark is when that starts. We'll see main engine cutoff, or MECO, followed by stage separation, and then the ignition of the 2 BE3U engines that power the second stage. The fairings will jettison just before the 4 minute mark in flight. Fast forwarding in this animation, the ESCAPADE spacecraft will jettison beginning at T plus 33 minutes and 18 seconds, with the second one separating 30 seconds after that to begin their journey into a loiter orbit around Lagrange point 2, which is about 1 million miles away from Earth. Meanwhile, the first stage booster, named Never Tell Me the Odds, will perform a flip and use the 3 gimbaling BE4 engines to perform the booster re-entry burn at about T plus 6 minutes and 48 seconds. That'll set up the landing burn to begin at T plus 8 minutes and 27 seconds, which will start in a 3, then pivot down to a 1 engine burn, with a touchdown on the Jacklyn barge anticipated at about 9 minutes and 9 seconds post liftoff if all goes to plan. Once the booster is down on the barge, that little rover will go out and connect to the booster. That is the Recovery Remotely Operating Vehicle, or the ROVE, and it provides power, communications, and pneumatic links between the booster and the barge itself. It takes about 4 days following a good touchdown and safing the vehicle to bring it back into Port Canaveral. Speaking of the Jacklyn barge, here's a live look at that vehicle, or that vessel, and a look beneath Glenn Stage 1 at those 7 BE4 engines that will power this rocket at liftoff. We're less than 5 minutes away, less than 1 minute away now from the planned terminal count beginning. Coming up on the start of the terminal count in real time. 4 minutes and counting.
Going to start being able to hear our mission ops, Patrick Moore.
AFSS timer enabled.
Terminal count system is active. From here on out, the vehicle is running fully autonomously on software.
Disengaged. Magic charge initiated.
How exciting here. We're ticking down in 3 minutes. We're going to launch this vehicle to space.
Just under 2 minutes. Vehicle should be switching to internal power in about 10 seconds. Past 90 seconds, vehicle should be on internal power. Confirmation of internal power coming up to the final minute. T-minus 1 minute and counting. Water deluge system should activate in about 20 seconds. Seconds. Watching for water deluge activation.
Launch control. Let's go.
Here we go. Water deluge system is activated. Water active. BE4 engines have ignited. And liftoff. Liftoff of New Glenn on NASA's ESCAPADE mission, the second ever flight of this 98-meter tall rocket. New Glenn has cleared the towers. We're now a little more than a minute into the flight here. Coming up next is max Q, the point of greatest aerodynamic pressure on the vehicle. Minute 30 in flight. Engines throttling back up past max Q. Coming up to the next few milestones, we'll see main engine cutoff, or MECO, at about T plus 3 minutes and 5 seconds. Stage separation, then followed by the ignition of the two BE3U engines on the rocket's upper stage. A little more than 2 minutes into flight, about a minute away from MECO. Past 2.5 minutes into the flight, we're coming up to MECO here. Just past the 3-minute mark. About 20 seconds from now. Coming up to MECO in a few seconds. Standing by for MECO. There you see MECO. Should hear stage separation next. Looks like a good stage separation. Standing by for the ignition of the BE3U engines. There we go. Coming up on 4 minutes into flight. Payload fairings should jettison momentarily. And it looks like we've got a good fairing jettison. And a really nice view of those payload fairings. Glenn Stage 2, and at the bottom of your screen, Glenn Stage 1. About 4.5 minutes into the flight. Coming up next, a big milestone for Blue Origin, one they were not able to accomplish in the first flight of New Glenn, the reignition of the 3 gimbaling BE4 engines on the booster. That's set to begin in about 2 minutes. A little more than 5 minutes into flight now.
Good on.
Confirmation of a good trajectory on both stages. Booster has reached apogee. Launch teams confirm good burn still on the upper stage engines. Coming up to about 6 minutes into this flight. Less than a minute remaining before the planned ignition of 3 out of the 7 BE4 engines.
See good data coming down from both GS1 and GS2. Body rates on both stages look good. The 3U engines look good.
About 6.5 minutes into this mission. Less than 20 seconds away from the planned start of the re-entry burn. Less than 10 seconds now. Right about the time we should see those engines come back alive for the re-entry burn. Standing by. Not seeing the start of the looks like the engines have reignited for that reentry burn. You can see those 3 gimbaling BE4 engines on the booster here. Engine cutoff. The landing burn should be beginning at about T plus 8 minutes and 27 seconds post liftoff. A little more than 8 minutes into flight here, waiting for the start of the landing burn. Really excellent tracking shot here. 8.5 minutes into flight. Should be seeing the start of the landing burn here momentarily. Call for landing burn. Standing by for a landing on the Jacklyn barge. Switching to the onboard cameras, we should see Jacklyn coming into view momentarily if booster's on track. There's the Jacklyn barge, looks like. And the touchdown is confirmed. Blue Origin becomes the second commercial company to propulsively land an orbital class rocket. Congratulations to the whole team at Blue Origin. Never Tell Me the Odds has beaten the odds and is safely down on the Jacklyn barge. Look at that. Couple little charges. Looks like they popped the base of a couple of those landing legs, and an understandably elated look at the Blue Origin team joining SpaceX and now being able to say that they have successfully landed a first stage booster on a drone ship. About 10.5 minutes into this mission, and a great point of success for Blue Origin. Assuming a good booster recovery and a trip back to Port Canaveral, teams are planning to use this booster to fly their first robotic lander to the moon's south pole, the Blue Moon Mark I, sometime in early 2026. Teams say the Glenn upper stage continuing a nominal burn. About 1,600 kilometers downrange. We're coming up to SECO 1 here in about a minute and a half when those two 3EBU engines will cut off. On the left-hand side of your screen, you're looking at the booster, Never Tell Me the Odds, safely down on the Jacklyn barge. You're looking at the upper stage engine that is reaching the end of its first burn, SECO 1. You're now watching a replay of the landing of Never Tell Me the Odds in the big box on the left-hand side of your screen. Confirmation of SECO 1. The 2 BE3U engines have cut off. The upper stage now in a coast phase that will last until about T plus 25 minutes, when the engines will reignite for a burn lasting about 1 minute and 44 seconds. You're taking a look now at the celebration in Huntsville, Alabama, the home of Blue Origin's rocket manufacturing center, where those BE4 engines were manufactured as well as tested at one of the Marshall Space Flight Center test stand. Another watch party here, and looking back with a celebration at Rocket Park here in Florida near the manufacturing site. We're back looking at the launch pad here, waiting for views to be reestablished for the New Glenn upper stage, if Blue Origin is going to be bringing those camera views back. Here's a look inside the control room as the booster was coming down, celebrating the moment when Never Tell Me the Odds touched down on the Jacklyn barge. T plus 16 minutes, 13 seconds and counting into this mission right now. Mission Control reports good data still coming down from Glenn Stage 2. Good tank pressure. Getting a live telemetry map here showing where Glenn Stage 2 currently is, heading out over the Atlantic. You can see where the booster landed on the Jacklyn barge just on the horizon there. confirmation that systems are operating nominally at this point on Glenn Stage 2, so continues to be a good mission so far beyond what was certainly the most exciting, it seems, for the blue team, but considered the secondary mission, of course, recovering that booster. The primary goal of this flight is still ahead with the deployment of NASA's ESCAPADE spacecraft, manufactured by Rocket Lab, with science spearheaded by University of California, Berkeley.
Blue Origin, what ESCAPADE can do is tell us about what happened at Mars billions of years ago. It used to be habitable with oceans and lakes of water, but then something happened to its atmosphere. All of that water evaporated and dried up, and now we have this desert that it is today. And that brings us to today, which is that if we understand Mars's atmosphere and what it's doing, we can help protect future assets, especially not just robots landing on the surface, knowing how they enter that atmosphere safely. But it's not an if, it's a when humans actually go to Mars. And that brings us to our future. And so ESCAPADE, working with a company like Blue Origin, is going to change how we get to Mars and how we protect our assets there, our robots and our crewed flight.
What is the most exciting part about being a part of this project for you?
So the thing I'm the most excited about is that this is going to change how we go to Mars. So we've never done a mission like this at NASA or really in any other part of the world. And using all of these commercial sectors where we're pushing the envelope and we're doing incredible kinds of technology to get low cost, high risk science and get our taxpayers the best bang for their buck, you can't beat that.
So can you dive in a little more and explain how both commercial and academic
Now just
partnerships
past 20
lead
minutes
to
into
something
flight,
like
less
ESCAPADE?
than 5 minutes
Absolutely.
remaining in the coast.
The
GS2
academic
systems
environment
continue
means you just get to think
operate
for a
nominally throughout
living.
the coast
You
period.
get to think of these ideas, and this is where the theory comes in. But then the commercial partnerships, these are the experiments.
And we are now
These are the
seeing
people
tank
who make
pressures
it happen.
increasing
They
in
make all of
preparation
our
for the next burn.
dreams in academia, all of our dreams at
And good system
universities
response.
happen. And NASA then enables that. So you have this like perfect 3 points of this like pyramid to do incredible and great things at places like Mars.
How long has this project been underway? I mean, when did the first idea for ESCAPADE come about, bringing it to today?
Rob and I started thinking about this mission back in 2016 and 2017, and it took years of planning and years of iteration until we found the right
Now just
partners,
past 21
we
minutes into
found the
flight.
right
Data quality
spacecraft,
coming
we
down
found
from
the
the
right
vehicle
rocket,
continues to look
and
good.
here we are today. So we are coming up on 10 years in the making to make this
Body
happen.
rates
So 10 years in the
continue
making to get us to the point
stable
of
throughout
launch.
the
And
coast.
then once it launches, you have another, let's see, we're in 2025, 2026, 2027, 2028, 2029, another 5-ish years of getting the
Tank
data
pressures are continuing
before you
to
get the
increase
data
as
and then
expected in
processing that.
preparation for the
5 years of science to me sounds like heaven. So I think for some folks waiting is hard, but for the science team, we are ecstatic. We will take every single bit of data that we can get. And again, with working with our partners, being able to get all of that data and enabling this incredible opportunity to explore not just Mars, but actually the entire trajectory there, that's science waiting to happen.
What is your message to all the collaborators who've had hands on ESCAPADE at this moment in time as you're kind of just waiting for it to deploy?
To all of our collaborators,
3 minutes remaining
thank
to
you
engine
from the
ignition.
bottom of my heart. We're so excited. We can't wait to work with you, and we're going to totally change how we do things at Mars. As we get ready for launch, my final thoughts are go ESCAPADE, go Blue, and we're so happy to be here.
And we're so grateful to have you on the team.
Thank you.
Thank you so much. Yeah.
We're now T plus 22 minutes, 49 seconds and counting in real time. Coming up next again is reignition of the two BE-3U engines on the rocket's upper stage for a burn lasting just a little bit less than 2 minutes in duration. Seeing more celebration from the Blue Origin team. This is up in Kent, Washington. This was where Blue Origin was originally building their BE-4 engines. A lot of that manufacturing has shifted to Huntsville, Alabama now. Coming up, we're just about 25 minutes into this mission so far. We are approaching the ignition of the two BE-3U engines. Not sure if Blue will share onboard cameras if they are able to. Confirmation of ignition. Good callouts of expected control of the two BE-3U engines. This burn set to last about a minute longer in real time. Good body rate control. Data quality good. About 20 seconds remaining in the burn in real time. Burn should be wrapping up in real time, standing by for confirmation. Confirmation of SECO 2. A little bit more than 27 minutes into the flight in real time. We are just about 6 minutes away from the deployment of the first of the two ESCAPADE spacecraft. About 28.5 minutes into the mission so far. Again, separation of the two ESCAPADE spacecraft will begin at about T plus 33 minutes and 18 seconds. Spacecraft will separate one after the other with about 30 seconds between the two deployment milestones. About 5 minutes after that, the Viasat technology demonstration is set to activate. This technology demonstration from Viasat is called InRange. It's the first time that they'll be demonstrating this. It's part of their contracted work with NASA's Communication Services project. In a statement to Spaceflight Now, Viasat says, quote, InRange is a specific launch telemetry data relay service designed to support launch providers with responsive, real-time data transmission during launch using Viasat's L-band network. Viasat, in addition to this demonstration today, they plan to launch another InRange demonstration that's coming up sometime in 2026 as currently anticipated. Unclear at this point in time, though, which mission will be supporting that second InRange demo from Viasat. We're a little more than 30 minutes now into this mission, NG-2, carrying NASA's ESCAPADE payloads. Those twin satellites are now less than 3 minutes away from the start of the deployment. Glenn Stage 2 in preparation for the start of the separation sequence.
My friend, I have to tell you. So our son's in Germany, in Heilbronn, and our daughter-in-law.
Got a nice view now of those two ESCAPADE spacecraft. Spacecraft and the rocket's upper stage are now in the separation attitude. About 31.5 minutes into the mission, we're roughly 2 minutes away from separation. Just over 32 minutes now into this mission. Just about 1 minute away from the start of deployment in real time. Glenn Stage 2 passing over the southern part of the African continent. Again, we are less than a minute from the start of the separation sequence for these two ESCAPADE spacecraft. T plus 33 minutes and counting. Standing by for spacecraft separation. The first spacecraft that's set to deploy is the one named Blue. That should be followed by Gold about 30 seconds after.
Set. And we have good indication of ESCAPADE Blue spacecraft
We do
separation.
have payload separation confirmed. Go Blue. Second payload coming up, as we mentioned. Just about a couple of seconds more here.
Standing by for spacecraft 2 set.
Oh, beautiful live shot from over 700
ESCAPADE
miles
Gold
in
separation
space.
confirmed.
And Gold has separated. Congratulations, ESCAPADE. Both Blue and Gold have successfully deployed. We have
And with the deployment of both spacecraft Blue and Gold, and actually you can see the little robot that I mentioned earlier in the broadcast, that is, or was the recovery remotely operated vehicle, the ROVE, that will connect to the booster and help with the saving process, providing power communication and pneumatic links between the Jacklyn barge and the booster. Never Tell Me the Odds. We've seen this in animation before. It's cool to see the actual ROVE in motion. Once the booster has been safed, teams can board the Jacklyn barge. For now, there remains no souls on board. Now T plus 35 minutes, 24 seconds into this mission. The start of the Viasat tech demo will begin at about T plus 38 minutes and 48 seconds. A little more than 36 minutes into this flight, less than 3 minutes till the activation of Viasat's InRange tech demo. A little more than 37 minutes now into the mission. We're just about a minute away from the start of the Viasat tech demo activation. +38 minutes into the mission now, less than 1 minute remaining till activation of the Viasat tech demo. T plus 38 minutes, 48 seconds and counting. In real time, the Viasat tech demo should be active. Waiting for confirmation from Blue. And confirmation that Viasat's InRange tech demo is powering up. This is the first of 2 Viasat payloads that is flying today. Of course, the Viasat 3 F2 spacecraft set to be launched by United Launch Alliance later on tonight. Flight of the Atlas V set for 10:04 p.m. Eastern. Just about 5.5 hours from now. So with the activation of the Viasat tech demo, that will run for an amount of time that Blue Origin didn't outline. Unfortunately, the pre-launch briefing was when the government shutdown was still happening, so we don't know exactly how long this tech demo will last, but the planned end of mission for Blue is about T plus 1 hour, 41 minutes, and 54 seconds. I suspect that we'll lose the views of this telemetry map probably momentarily. Yep, there it goes. So let's go ahead and wind the clock back, see some spectacular views of liftoff that were captured by our launch photography, videography team. Let's start with a replay beginning with our view here at the Kennedy Space Center press site. Now on to P. Carson's tight tracking view. Should hear the strong, or see the strong backward track. There you go. Again, you're watching a replay from Pete's tight tracking camera. Next up is Adam's tracker from Jetty Park. Unfortunately, the cruise ship makes a better wall than a window, so it took a second, but quickly got the views of the rocket back. John Pisani's wide shot. As we're watching these replays, let me thank a few folks for your support throughout the latter stages of the pre-launch into post-liftoff part of this mission. Big thanks to Janine, one of our channel members. This is Chuck and Jen's view from Merritt Island. Janine says, third time's the charm, go blue. Hello, Will and Mods. Jay with a $2 super chat. Thank you, Jay. Liam Fogarty with a €10 super chat, asking for a shout out to Aoife Fogarty from Limerick, Ireland, who is 10 and watching tonight. Hello, Aoife. Glad you could be with us for this big mission for Blue Origin. Hope you enjoyed the broadcast. Jay with another super chat, rocking on, saying, let's go Big Blue hydrogen rocket. Michelle with a very generous $20 super chat. Thank you, Michelle. Asking for a shout out to Luke and Jordan LeBlanc, who are 4 and 5 watching. Hope you guys also enjoyed the show. Steve Rose with a $10 super chat. Thank you, Steve. Asking how much of the engineering of the webcast that I myself do, like resetting the countdown clock and switching the angles in the pictures. Thankfully, I am usually not the one who is doing all that. Usually either Stephen Young or John Pisani is handling the switching of cameras, but depending on what all is going behind the scenes, I do have the power to adjust the countdown clock and switch from various views, call it video and whatnot, so it's a team effort, certainly. Mariana, Texas, marking 3 months with us as a member at the pad leader level. Glad to have you still with us. Mariana says, great reporting and filming. The commentary is wonderful, and I'm glad I found your channel. That's very kind of you to say. Really appreciate that. Thanks as well to Jeremy Fritz with a $10 super chat, saying the stream is going well. In exchange, the announcer also has to say a tongue twister. I feel like there have been a few of those today. Not sure which one you're referring to in that specific comment, but definitely helps to do some vocal warm-ups before long broadcasts like this. Tim H with a $5 super chat. This coming in before launch, of course, saying wishing Blue Origin a successful flight. And as we saw, they certainly had one. Cat Vision with a $2 super chat. Thank you, Cat. Carrie Alexander joining us with membership at the pad leader level. Welcome aboard. Deb thanking us for the coverage with a $5 super chat. You're very welcome, Deb. Thank you for your support today. Ryan R. writing in after the booster landing saying, unreal. Congratulations to Blue Origin on landing a booster on their, well, technically second attempt. The first time they had also wanted to land the booster, so you're telling me there's a chance, and the engines failed to relight as expected, so still, landing a booster on their second ever try is a remarkable feat, and the Blue Origin team should be, as we saw in the broadcast, very much are elated at that. Diamond Zoe with a $5 super chat saying, never tell me the odds. Go Blue Origin. Thanks for the great coverage, Spaceflight Now. Thank you, Diamond. And thanks to channel member moderator Astro Joe for gifting Spaceflight Now membership, as well as Psychonaut69. So to our new, actually Tim H also gifted 5 memberships as well. So to our 7 newest gifted members, welcome aboard. We're glad to have you with us, as we are to Laura Blackman, who joined of her own accord. But to the 7 gifted members, be sure to thank Joe, Tim, and Psychonaut in the live chat if you haven't already, if you're still hanging around with us. Also thanks to Donna Hayes for a $10 super chat saying, congratulations, Blue Origin. Never tell me the odds. Way to go. And with that, we are rapidly approaching the end of our broadcast. But before we go, Let's go ahead and take a spin with our mission stats as they currently stand. With a good liftoff and fortunately a good landing. That was the first flight of this booster. Never tell me the odds. This was the second New Glenn launch of 2025. This was Blue Origin's second orbital flight from LC-36 and the 113th overall orbital launch from this pad as well. This was the 95th launch from Florida this year, the 152nd from U.S. soil, the 166th launch from a U.S. rocket company, the 262nd orbital launch attempt around the world. There have been 6 orbital failures so far this year. Thankfully, New Glenn this go-around was not one of them. Here is where the pie chart now currently stands. Before we sign off, we saw some of the video from our photographers. Here's a few still images that they were able to capture of the rocket on its way uphill. There's a picture as the cruise line passed in front by our John Pisani. Moving right along, here's one from Michael Caine. This next one is also shot by Michael. Let's go to one from our Adam Bernstein. Nice shot of liftoff. And then back to Michael for a couple more here. A nice crowd reaction shot as New Glenn took flight with the lighthouse just off to the side there on the right-hand side of the screen. And finally, one good shot of New Glenn in flight. And folks, that will do it for us today on the first of what is billed as a double launch day for us here on Florida's Space Coast. Always busy, always something to keep us running around, but we certainly appreciate you for all of you who have been with us for the majority or just part of this 4-hour broadcast. We certainly appreciate your time and attention, and thank you for being with us here at Spaceflight Now. Want to thank our friends Pete Carsons with Max Q Productions and Chuck and Jen Briggs with C&J Images for their support in tracking New Glenn, sticking with us throughout the holds earlier in the count. Thanks as well to our moderators in the chat, to Astro Joe, Rick Donner, and Jeff Hansen. Also thanks to one of our channel members, Cumulus Granatus, for helping answer folks' questions in the chat. Big thanks to our photography team. You saw their work in motion. You saw their work as stills. Be sure to give them a follow on X to see what else they captured. We just gave you a little taste here on the broadcast. Adam is at ABurn NYC, Michael Caine at MD Caine Jr., and John Pisani at John Pisani Photo. Be sure to follow Spaceflight Now also at Spaceflight Now on X, Threads, Blue Sky, and or Facebook. Our Spaceflight Now editor, Stephen Young, has been running the technical operations of the broadcast. Most importantly, we want to thank you for, once again, joining us for whatever part of the show you were able to hop in for. We've got about 5 hours remaining before United Launch Alliance steps up to the plate once again with its Atlas V rocket, sending to space one more mission for Viasat, the Viasat 3 F2 spacecraft. We'll be back on air right here on the YouTube channel with live coverage beginning 1 hour before that launches. So for now, for all of us here at Spaceflight Now, I'm Will Robinson Smith. Remember, be good to yourselves, be good to others. We will see you next time, folks. And until then, bye-bye.